The best part about supervised learning is the supervised learning has its own supervisor. But wait, what does that supervisor comes from? The supervisor is basically your level data. And supervised learning is one of the most useful and interesting types of machine learning. Machine learning is a process in that you can build your own model. But why do we need to build a model using machine learning techniques, right? So basically machine learning help us to reduce the human races by making a model using the current technologies. Now we have a 3 parts in machine learning. We have supervised learning, we have unsupervised learning, and we have reinforcement learning. But what is the difference between this machine learning types and the traditional programming? So basically in the traditional programming, you need to start putting your data to your program, and then you need to write program for each and every time. And then only you will get the output. But in the case of machine learning, you just need to put your data and you just need to make your own model. And from that model, you will get the output. But whenever you are going to give a new data to your model is ready to work for you. So this is how machine learning reduces the cost and reduces the human resources as well. Now we will have a look at what is supervised learning. So supervised learning is basically supervising the machine using a supervisor. So the companies like Google, Ola, Uber are currently using machine learning to focus their business and also enhance their business quality as well. So keep that in mind, we came up with a tutorial where you will get to know about supervised learning. But before start the tutorial, please go to Great Learning Academy where you will get almost 80 plus free courses, and after completing your course, you can claim your certificate. And if you want to do these courses in your mobile application, that is also possible using Great Learning app. And if you want to get updated with the new content like this, then please subscribe Great Learning and also like the video as well. So let's get started with the tutorial.
So how many lines we can make it? How many regression lines we can make it for this points or for this data?
I think this is pretty evenly distributed, right? So I think maybe may not be a good example, but then I can at least by looking at the data, we can draw one line that closely distributes all the data points on both sides.
Is this the best fit line? Slightly I changed the slope, but intercept is same. Is it the best fit?
3 points look little have more distance with the line. The previous one has only 2 points.
Okay, fine. What about this?
This one looks better. The intercept changed one. Slope change and intercept change. Only 2 are outlier like they are Rabe.
Okay. You should take mean average square, average error. When you take the average error, right? Okay. Then what will happen? These 2 points are far away. Maybe average error may increase. This red line, it is slightly near to these 4 points and also near to these 2 points. Average error you don't know whether this white line or red line, which one will give the better average error or least average error. Okay, what about this line? It is almost equally distant to all the points.
Yeah, this is exactly what my doubt is. So this here, right? So do we look at a model where x becomes a 0 and then y becomes 2? Would that be my reference point? And then find out whether the blue or a red line is accurate, because like you said, red line and the blue line are pretty evenly distributed on both sides.
So which is the best fit line? So the answer here is, if you get the least square error, you draw a line, you calculate the least square error. Okay. So let's say this line is beta naught plus b1 h2 plus e2, you just leave it. There's some random error, you forget that one.
See, Yuraj, I think my question is more with this specific example and this specific theorem also. See, I'm still not clear on how E1 head and E2 head and E3 head are kind of calculated.
Okay, fine. How to calculate that one I can say. How to calculate is clear. It's very simple. Okay. How to arrive see, our objective is whatever the line you draw, that should have least error with all the point. Average error or sum of the errors should be not average error, sum of the errors should be least. Okay. Sum of the errors should be least. Least sum of squares. Square errors. That is our objective. Whatever the line you draw, I should have less error. Am I right? Do you agree with that, Chandra?
Yes. Yes.
So, what is the error here? How do you define error? So, this is the value, my x. This is our x value, and this blue color line is the regression line. So, the predicted value is this one, y cap. But actual value is this one. For the same x, actual value is this one. So, what is the error is y minus y cap. That's it.
Okay. Okay.
So, that is the epsilon 1, that is error. Even I calculate for this point, what is the error? For this point, what is the error? For this point, what is the error? I calculate it. I error squared. Each error I squared it. And I did the sum. And if my sum is least value, so for this regression line, this is the error. I will draw another regression line. I will draw another regression line, something like this, and I calculate the error again. Okay. So, and I will check which is having least error. Then that will be the best line for me. Do you agree with me or not?
Yeah. Yeah.
But how many lines you can draw between for all these points? How many possible lines? So I draw one line, blue color line. I draw this violet color, and I calculated the error. So error 1, error 2, error 1 means line 1, error 2 is for line 2, error 3 is for line 3. So I mean to say sum of square errors. Instead of that, I will write sum of square errors. Sum of square errors, SAC, for line 1, this is something like alpha, not alpha also, I don't use those words, maybe 10. Sum of square errors for, this is line number. Sum of square errors for line 2 is 20. Sum of square errors for line 3 is maybe 5. So which is the best line?
Third one.
Third one. Okay, if it is 3 things, it is easy. Maybe if you build 10 things also, it is easy to compare. But how many lines are possible for these points? Theoretically. Infinite. So you are linear. So do you need to do infinite lines and check it?
Be very time consuming and not an efficient way, right?
No, it is impossible.
It's impossible.
Yeah.
Infinity line?
In a way, it is not possible.
Yeah.
So what is the way?
Maybe 2 lines. Number of lines touching 2 points. That will be limiting.
So you limit, okay, I will take randomly 10 lines, and in the 10 lines, which is best? You mean to say?
No, maybe one, like I'll find out 2 points. That will be maybe maximum, minimum kind of thing, and plot between them.
So you, out of total data, you will consider only 2 points.
to start with,
Okay.
and adding some variations in that.
See, you have, okay, which 2 points you will take, for example? You take this point and you try to draw a line between them. So then
Right.
then it will become like this.
Right.
Is it the best fit?
No, definitely.
So
But we'll find out the errors. Yeah.
If I have 1,000 points, you are ignoring all of them, but you are taking only 2. Okay, and one more question. How do you know which points you take? Another complexity is included.
Right.
If I have 1 million points, then which 2 points you will take? So 1 million, if you have 10 points, how many combinations it will come, 10 C2. 10 C2, how much it is? 10 into 9 by 2, right? 45 combinations it will come. Okay. So if it is 1 million points, then you just imagine. So in that you have to pick 2 points and draw a line. You are adding the complexity to the problem. Further complexity. Let's say you have a y theta naught, theta 1 x1 plus theta 2 x2 and so on, theta m xm, something like that. There are m or n, let's say. This is your regression line. So you want to find theta naught, the coefficients are theta 1, theta 2, theta 3, coefficients. So you know x1, x2, x3, x4, all are columns are in your data. Those are independent variables. Theta 1, theta 0, theta 2, theta m are coefficients. How do you find these coefficients? Best fit line means finding the coefficients only, right? Do you agree or not?
Yeah.
So for which coefficients your error is less. So let's say you predicted one value y cap, then sum of square errors is I remove theta m. Let's say you have n columns or something. So what is the sum of square errors? Sum of square errors is sigma I equal to 1 to m. Let's say you have a data set. This is x1, x2, x3 and so on, xn and y. We have a data. Let's say you have m rows. Row 1, row 0, row 1, row 2 and so on, m rows you have. So then sum of square errors is for each row you have to find the error for each data. Then y minus y cap whole square. Is this the sum of square errors? Do you agree? Is this the formula, mathematical formula?
Yeah.
So what is our objective function is? Minimize this. So you have to find the minimum value. So to find the minimum value in mathematics, we have it. If you give any equation, if you ask any minimum value or maximum value, what we will do? We use partial differential equations, right? Pre-math have you gone or not? Have you gone through the pre-math? Okay.
Yeah.
Yeah.
So sum of square errors, let's say that one value is j. So our objective function is minima. If you want to find the minima of a function, you have to use partial derivatives. Okay. So our objective function is we have to find the minimum sum of squares. So then if any minimum sum of square errors is less, then our regression line is best line. That is the best line. So Our target is we have to find the minimum sum of square errors. So least sum of square errors is nothing but minimum sum. So here, how do you do mathematically? Then j equal to cost function. Our objective function is minimization, minimum sum of square errors. So then what we will do? J equal to 1 to m. I am taking 1 to m means we have m rows of data, that is 1. And y minus y cap in the sense, what is y value? I will substitute theta naught plus theta 1x1 plus theta 2x2 minus y cap, which is we predicted, whole square. So this is the one. Then if I want to minimize it, I will do the, what I will do? I will do the partial differentiation with respect to what? With the theta or with the x? With the theta or with the x? With respect to what we have to do partial differential equation?
Theta?
Exactly. So we want to do the partial differential equation with the theta. So when you do the partial differential equation, this one also theta I. So let's say I is the value between 1 to n, because let's say you have n features, a value is 1 to n. Then if you do that one, we have to do the partial differential equation. When you do the partial differential equation, so if you want to know dou j by dou theta 1, then what is the answer? I am removing the sigma function. Let's assume you are having the sigma function, so I'm not writing. Theta naught plus theta 1 x1 plus theta 2 x2 minus y cap multiplies, when you are doing with theta 1, then theta 1 into x1 again we have to differentiate, then it will come x1. So this is dou g. This is your partial differential equation. Same way you will calculate. Okay, I am writing this much mathematical thing.
So just a clarification here. So you are using this partial differentiation. That means dj by d theta 1 will be the thing, or it will be dj by dx. And here you are doing the partial differentiation on the right hand side of equal to.
Right hand side, yes. When you
It should be left hand side should be dj by dx, right?
dj
Not
by
dj
d theta 1.
No, then you should not be doing the second differentiation which you are doing in x1, because then it will be dj by dx, not dj by d theta 1.
So first it is square term. When you do the first time, then square term will go 2 multiplies. Then
No, I understand that. I understand that what you're doing here. I am saying
let
that.
me tell you. 1 minute.
Yeah.
So then this term will be left out because we are doing with theta 1. Then theta 1 into x1, you do the partial differential equation with dou j by dou theta 1. Then theta 1 will become 1 and x1 only will be left out, right?
No, that's what I'm saying. So if suppose I'm using partial differentiation, so it will be df by dx. Okay. So f is not, f cannot be done differentiated directly. So what we do is in f, we will take one term as t and we'll do dt by df by dt and then dt by dx. Okay.
That is chain rule. That is chain rule.
So that's what we are doing here, right?
No, here we are not doing chain rule. Directly, j is a function of theta.
So in the, okay. Oh, okay. Got it. No.
So this is the one. Okay, till now I told this much mathematical. Till now I did not say how to find a best fit line. So there are infinite lines possible. How to get the best fit line? Okay, I will tell you one more thing. If you draw, let's say you don't have theta naught, you have theta 1 x1, only you have one variable, y versus y equal to theta 1 x1, let's say. We have only one variable, y equal to theta 1 x1. So y equal to theta 1 x1, then if I substitute here if I substitute, then what will be the formula? I will write in different color, or I will go for next page. Y minus y cap whole square sigma. Okay, y equal to, let's say, theta naught plus theta 1 x1 plus theta 2 x2. Instead of intercept, theta naught is intercept. Let's say it is going by 0, and we have only one variable x1. So you assume that there is this term also not there. Then j will become sigma theta 1 x1 minus y cap whole square. Y cap, what we are going to predict? Y is the value theta 1 x1. Now, if I draw this curve, how it looks like? J equal to some value square. How it would look like? What is the shape of this curve? It is similar to
Parabola?
Yeah, exactly. It is similar to A equal to B square, right? So it is a parabolic shape. So it is a parabola. So our target is to find the minimum. How do you find the minimum? By differentiating. Partial differential equation. Dou j by dou theta 1 equal to, okay, you do the minimization function, 2 into y minus y cap into theta, no, it will become x1. Y minus y cap, y I wrote is instead of y, maybe I can write theta 1 x1 for not to confuse you. So this one. Okay, if you draw the partial differential equation, then you will get the minimum value, and you can take that value and you can substitute in your equation. But what will happen is, it is very difficult to do directly this kind of partial differential equations on the data set. Mathematically, it is very complex because inverse and everything will come into the picture. So what we will do, we will go for gradient descent optimization algorithm. What gradient descent optimization algorithm will do? Okay, before that, let me complete it. So when you take a slope and you can make it 0, you know already x1, you know what the predicted value, you know here again x1, 2 is constant, you can find theta 1 here, right? When you do the partial differential equation, if you want to calculate the minima, then you have to do the partial differential equation. You already know, and you have to equate to 0. When you equate to 0, you already know x1, what is the value? This is your column value. Y cap, this is the predicted by your linear regression model. And x1, again, you already know. 2 is constant. So theta 1 is unknown value. We can easily calculate theta 1. So then you will substitute here. Let's say theta 1 equal to 2. Then your value will be y equal to something like 2x1. If you have some more values like that, 3x2 or maybe 7x3, something like that, you can create it. So what I am trying to say here is, by doing the partial differential equations, you can calculate your coefficients directly. And you can, once you calculate the coefficients, your best fit line will come here. But the challenge here is, we can do, because if you want to calculate a minima of any function, you do the partial differential equation and you will get it. The problem here in mathematical is, it is very difficult for the, if you have, because partial differential equations calculating is very difficult and computationally complex. So what we will do is, we will use gradient descent algorithm. Have pre-mass gradient descent algorithm. Is it explained? Gradient descent algorithm. Is it explained or not? I did see that one. That is why I'm asking. Freeman. Okay. Just Google it, not an issue. What is gradient descent algorithm? How to use in linear regression? Okay. In some of the interviews, if you go, you should not get surprised. That is why I'm covering here. So, calculating partial differential equation directly, it is very complex actually, because inverse functions and everything will come. It is very, very difficult. So, to solve that issue, we got gradient descent optimization algorithm. What gradient descent optimization algorithm is? See, here it is our minimum. When you plot this error function, you got this minimum. Then what you will do? Gradient descent. Gradient is nothing but slope. Descent means down. So you have to come down slowly, step by step, in a small steps, and you will come to the minimum. So instead of coming directly from here to here, it is very difficult and complex. What you will do? You will come slowly, step by step. So this is called gradient. Who will do this part is gradient descent algorithm. So just Google it and try to understand what is gradient descent algorithm. So what this gradient descent algorithm will do is, okay, I don't want to go to complete too much again mathematics and to confuse you. It will come step by step slowly. In every step, it will try to come to the minimum, to this place. As soon as it converges, the optimization algorithm will stop itself. Okay. So this is called gradient descent algorithm. So we don't do directly the partial differential equations. By using gradient descent algorithm, we will arrive the minimum value. So please. So why I want to give all these flavors and words, gradient descent algorithm, all those things, it's important actually. So go through this. Who are interested in mathematics, complete mathematics behind this, please go through that. Google it, you will get anywhere. Many articles will be there, and understand gradient descent algorithm and how to apply this in this linear regression. Okay.
So this gradient descent algorithm is quite important in linear regression.
Quite important. See, if you do partial differential equation, you will get the minimum value, and you will. Okay.
Yeah. True. That's true. I understand that. Okay, what you are trying to achieve here. What I'm asking is that okay, do we use it in real life a lot?
When you import scikit from scikit-learn linear regression, what is happening behind the scene? It is using gradient descent algorithm in the background.
Okay. So we are actually using gradient descent only to calculate all these values R square and adjusted R square.
No, not R square. To calculate the coefficients.
Coefficients only, sorry, that coefficient.
Yes.
So we are using gradient descent only there in
gradient
Python.
Descent. Yes.
Okay.
You are implicitly you are using it, but as you are importing the library and you are using one line of code, in the background many things are happening. To come to that
okay.
point.
Okay.
So if someone asks you, how do you calculate the coefficients in linear regression? What is your answer? Now tell me.
Using gradient descent algorithm?
Using gradient descent algorithm?
Yeah.
So, see, to get the coefficients, our objective function is minimizing the sum of square errors. Okay? Minimizing the sum of square errors, we will achieve by using gradient descent algorithm. Okay? I will tell you one more time. Minimizing the sum of square errors is our objective function in linear regression. So whatever the line you fit it, you should have minimum sum of square errors. So how do you achieve it is, you can do by partial differential equations. Because for any function, if you do partial differential equation and equal to 0, then you will get the minimum value. So that is fine. But we cannot do partial differential equation. It is complex. That is why we will take the help of gradient descent algorithm. Clear?
Yes.
If it is simple data, right, something like 3 to 4, not 3 to 4, 3 to 4 columns and 100 rows of data, then it is very easy actually. Direct to partial differential equation. But when the number of dimensions increases and number of rows increases, it's very, very complex. So instead of directly doing the partial differentiation, we will take the help of gradient descent to do that step. I did not say learning rate, all those things. Maybe when we are covering the neural networks, I will revisit this gradient descent and the learning rate and many things are there. Till that time, just I want to give the flavor of what is happening behind the linear regression. So whenever you do linear regression dot fit, what is happening behind that? There are many things, many calculations are going on. So that is fine. Yeah. So to say whether our model is good or bad, what are the metrics we have? If you don't understand math behind that, it's okay, not an issue, because you are not using in Python, Jupyter Notebook, and those things. After some experience, you won't sit and write the code also. You will see whether that person is using the right algorithm or not. So what are the metrics to say our linear regression is good or not? So I built a linear regression model and I got, so I don't know whether it is a best fit, not best fit, whether it is a good model or bad model. So I use the linear regression and let's say I used random forest regression, I used support vector regression. Let's say I have built 3 models for my data set. And I would like to know which is the best model, linear regression, random forest, and support vector regression. Which is the best? How do I know?
Yeah, I think on the test data set, all of them, we will look at the performance of all of them and look at the RMSE.
Exactly.
And
RMSE.
the R square.
RMSE, R square. What else?
MEP also, mean adjusted.
Mean absolute error. Okay. Mean absolute error, most of the people won't use it. R square and RMSE is more popular. Okay. In R square and RMSE, which one you will use?
You look at RMSE to ensure that the error is low, and R square to ensure that all the coefficients are considered. All the coefficients or all the X independent variables are considered. So according to me, both has to be looked at.
Yeah, both has to be. R1. If you want to compare linear versus random forest versus SVR, support vector regression, then we can use any of the thing, RMSE or R square. R square will be between, the scale is between 0 to 1. Okay? RMSE, what is the range for RMSE? What is the range for RMSE?
0 to infinity.
So that is the one. Just a scaling issue. R square 0.21 and RMSE 0.2. So 0 to infinity, say someone says my RMSE is 10,000. Does not look good, right?
Yeah, it doesn't look good.
Now tell me, RMSE 10,000 is a good model or not?
Only when we compare with another RMSE, we can come to conclusion, right?
So
Just seeing a number. Yep.
linear regression RMSE and random forest RMSE, support vector regression RMSE. Okay. Then if I say linear regression 10,000, then you have to ask what is the RMSE for random forest, right? And what is the RMSE of SVR? Let's say this is 999 and this is 100. So then which is the best model? SVR. Okay. In this way RMSE you can use it. Okay. Now I have built a linear regression model. My R square is 0.9. Is it a good model or not? .95. Is it a good model or not? My linear regression R square value is 0.94. Is it a good or bad?
I think R square 0.95 is considered as a good model.
Very good model, right?
Yeah.
Fine. So that is what. So when you say RMSE is good or bad, you need another model to compare. RMSE. If you want to say R square, if you give, of course, even you may ask what is SVR, what is the value of SVR here. But even without SVR, you can say linear regression is good or bad. It's 0.95 I got, then it is good or bad. Maybe probably you need not to go to another model. You need not to build any complex model, support vector regression or random forest regression, all those things. So are getting my point where R square and RMSE, what is the difference?
Okay, yeah, I understand.
So that so you can use anything to compare between the models, but within the model whether it is good or bad, RMSE direct by just using RMSE you cannot say, but by using R square you can say whether it is a good or better model, good or bad model. Okay, I have a question for you. Okay, anyway, this is the formula. Do you want me to explain the formula? What is SSE? What is SSTO? You can go through these slides. Y cap means predicted value. Here, this is the predicted value. This is mean value. This is predicted. This is actual value. This is actual. This is mean. It's good we have R square. I will give you a question actually. If RMSE is high, what will be the R square value? R square is high or low?
Be low.
Okay, good. Because RMSE means it's error. Error is high means your R square value is lesser. What is adjusted R square?
Dividing R with number of attributes.
Number of
Attributes.
attributes in the sense, number of features I can say.
Yeah, features. Yes.
Number of features.
Adjusted R square is a function of number of rows and number of columns, both. Okay. Usually, yeah, number of in the formula you will get both number of rows and number of columns. So, in this example, okay, before going to adjusted R square, let's say R square value here, how much it is? 6.5%. Because the data is spreaded, you are not able to fit properly. But here, R square value is 79.9%. Getting my point? So if you are fitting properly, your R square value will be higher. If you are not fitting properly, your R square will be low. So adjusted R square. Okay, what is the advantage of adjusted R square? Why we already have R square? Why do we need adjusted R square? Why we need to adjust the R square?
So we want to know if we bring in a new coefficient and a new independent variable, how much improvement it will contribute to the model. How much improvement it will contribute to the model accuracy.
If I bring new column, definitely my R square will increase.
Yeah, but what delta increase I get, right? That's what. Yeah, when you bring in a new coefficient and a new attribute, a new feature, the R square will definitely increase. But what's the delta increase? That's what we are checking.
Delta increase. See, you have three columns.
Okay.
We have three columns. Let's say I have three columns: x1, x2, x3, and my target variable y. Okay, I got R square. It's a 0.7. Okay. I increased x1, x2, x3, x4, and I calculate R square. I get some value, maybe 0.74. I will get delta, right? Why I need adjusted R square here? What is the delta here? 0.04. So 0.04 is increased. That is fine, right?
I think this will help to find out if X4 is whether to consider this feature or not, this column or not. If it is slightly increasing the success rate or R square, then it's not. It might add more error later.
You are almost partially somewhere intuitively are there, but you are not coming to the point.
Yeah, maybe we can avoid overfitting to the test data. I don't know.
Overfitting?
To the training data.
Overfitting, adjusted R square, no relationship.
Okay.
Both are different.
Adjusted R square is used to see if the variable is adding any value to the best fit model. So it will increase if the variable is adding value. If the variable is not adding value, then it will go down.
Value added or not, by taking the delta, you will get to know, right?
Yes, so it will go down, like R square will go down, adjusted R square will go down if the variable is not adding value.
If I add x4, I got 0.74. In this case, what it will go? It will go down or it will go up?
It has gone up. So it means the variable is adding value.
That is R square. Okay. What adjusted R square will play a role?
That's on the adjusted R square only, right?
No, this is R square 0.7. And I have included fourth column, and again I calculated R square. I got 0.74.
So that is the second time that you're calculating is adjusted R square, right? Or it is R square?
That is R square only.
Okay, I thought that it meant the adjusted R square.
How come? Same formula, right?
Same formula, but okay. Then I think I am not clear about this one.
I think R square is slightly increased, right? From the 3 variables to 4 variables. Adjusted R square will decrease, I guess.
You came to the point. So, adjusted R square will decrease. Yes, okay. What it will do is, I will tell you some small exaggerated way. You know, right? Polynomial regressions are taught in the Jupyter notebook. First, there was 9 columns. The value R square was 0.80. And when he made polynomial regression, the number of columns became 31. Then the R square became 0.82. Okay, number of features, number of columns, otherwise number of columns C and R square. So number of columns are 9.8. When he used polynomial regression, means the number of columns got increased, your value became 0.8. So from 9 to 31, there are 22 new columns we added, but there is minute difference, significant change in the R square. Am I right?
Yes.
So it means that 22 columns if you add, if it is really these 22 columns are influencing your target variable, then it would have gone around 0.95 or 99. But it did not happen. Why? Because this is statistical fluke. Even though they are not directly giving, even though these are not directly influencing as a mathematical fluke, because this just you are using the formula, right? This, after adding 22 columns, it did not spike up very high, the R square, it increased very less, 0.02. So it means that these 22 columns, extra columns are not influencing much. This slight increment is just a mathematical fluke. Because you are using formula. So then we should not say that. So someone cannot claim that because of this adding 22 columns, this is increased. That is not the reason. That is just a mathematical fluke because we are using a mathematical formula to calculate R square. So how to avoid this one? For that, people started adjusting the R square. How they have adjusted the R square is, if there is no significant difference after adding too many columns, then your R square, adjusted R square, I am writing A, adjusted R square. So when R square is 0.80, let's say your adjusted R square also will be approximately 0.88, approximately, need not be the same. Then when you added 22 more columns, your adjusted R square what will become is, instead of 0.82, it will become 0.79. So what your adjusted R square is telling is now, see your adjusted R square is decreased comparatively previous when number of columns are 9. So what you have to understand is adjusted R square, if you are using any columns which are not influencing the target variable, your adjusted R square will come down. It will be decreased. Or it will become same, like 0.81 instead of 0.79. So what this decrease in adjusted R square indicates that your columns are no more influencing your target variable. These columns are not giving any value addition for your model building. That it will say. So R square is 0.8 and you increase the number of columns, 9 to 32 it became 31, let's say. Your value is 0.82. So your R square is 0.80. I am giving some examples. It may become 0.79 or 0.78, let's say. In another scenario, we take it here equal to R square equal to 0.8. We added some columns, it became 0.99. Then adjusted R square 0.8 in first case, 9 column case. In this case, how much it will be? Tell some approximate number. Greater than 0.8 or less than 0.8?
Greater than 0.8.
Yes, because there is a significant difference from 0.8 to 0.99 in the R square. So adjusted R square may become 0.9. So what adjusted R square is there? If your columns are really influencing your data, then adjusted R square also will increase. If your columns are not really influencing your target variable, then adjusted R square will be reduced. It will come down. So that is the indication that whether your new features are really impacting your model or not, it will tell. So how to calculate the adjusted R square? This is the formula. What is this adjusted Haskell formula? N equal to number of rows. M equal to number of columns. If you want, you give some example and you try it, it will come. Gone through this problem statement?
Yeah.
Hello? Yeah. So what is our target variable? We want to predict default amount. Am I right? So losses in thousands is our target variable. So we have a bank. So the customer data is available. So we have to predict if that person is a defaulter, how much is the loss? How much bank may lose the money? How much they may lose? They may lose maybe $1,000 or $10,000, $2,000. How much they may lose? So let's say you go to the bank and they know your account details, they know your age, they know your years of experience, how many number of cars you have, they know, and whether your gender, they know, you are married, single, or not. So if they want to give the loan to you, or then they have to predict before giving the loan to you how much loss they will get if you become a defaulter. Means how much loss they may get if you will become defaulter means you will not become a defaulter on the day one of taking the loan, right? You will pay the loan, maybe after some, if you take 10 years of personal loan or something, or 3 years of personal loan, maybe 1.5 years you will pay. After that, you may continue or you may not continue to the pay because there might be many reasons. So they want to calculate how much money they will lose if they give loan to you. So that risk they want to assess. So if that loss in thousands is very less means, then they can happily give loan to you. And some disturbance is there, please mute if you are not able to. Yeah. So then if they give loan to you, if your model is telling, okay, loss in thousands if you give to one person is very less, then they may give with less interest rate. That business decision they can take, the bank can take it. The bank finds that, okay, if I give to the person, in future I may get a lot of loss. Then to reduce that risk, they may give with a higher interest rate or they may not give also. So that business decisions we can take. So here our job is, if we give all these details, if a person's or account or any customer details, predicting how much money the bank will lose. That is our job. So what we will do before. So I have this data set and I am calculating how many columns are there and how many rows. You can see here there are 15,290 rows of data is there. And we have the age column, years of experience column, number of vehicles, gender, married, losses in thousand. All these columns. Gender and married is in object data type. Loss in thousands are in float. And account number, age, number of years of experience, number of vehicles, all those things are integer. So if you see first 5 rows of data, it looks like this. Okay. So in this, now you can tell me what are the features. See, you got the features and you want to predict. Now can we directly go and build a linear regression model? We have the data. Can we go and build a linear regression model?
So I think we need to find out the features which are important to build a model.
Okay. So how do you find the important features?
Plotting the correlations between all the
Right. Great. So find the correlation. So what Pearson correlation will tell? Pearson correlation, what it will tell?
how much relational, like how much it is affecting the one variable with another variable.
So, affecting what? Linearly affecting. How much linear relationship does it have? Okay. How, if you change one variable, is affecting another variable linearly. So that will be a correlation. So if correlation 1 means, what is the meaning?
Highly correlated.
Highly correlated. If you change one variable, another variable also will change in the same order. Means if x increases, y also increases. If x decreases, y also decreases. That's fine. Correlation negative means, let's say -1. -1 is a good correlation or bad correlation?
Good correlation.
Good correlation. So when you increase y, x decreases. Sorry, when you increase x, x decreases. When you decrease x, y increases. Because y is depending on x. So when x changes, y will change. So you have to talk in terms of x only. Okay, that is fine. These are the histograms. Okay, here I converted these losses in thousands in lab format. Okay, that one I will come to you later. So I have just given the distribution. What is the age? How it is distributing? And number of years of experience. You can see here, this is a bimodal data. There are two modes actually. This is one mode and this is another mode. Maybe, and you can see there is a, and you can see losses is 1000 with respect to, if I draw a box plot, losses in 1000 with respect to married people. How can you understand the data from this? What do you understand from this box plot?
Losses are less with married people.
Losses are less with the married people, yes, comparatively. And single losses are high.
Yes.
So bank has to take care if the person is a single. Maybe this data set is definitely not from India. Bachelor's commitments are less, right? They can easily pay the loan. Okay. Yeah. So maybe without building linear regression model, you can tell to the bank that okay, single and male losses are a bit higher comparatively other groups. So unmarried guy, single person who is male, be careful. Try to give less loans to them. You can tell to the bank or not by seeing this data.
Yes.
So these kind of things, you see, if somebody gives the data set to you and if your bank asks you, I want to predict this one, by doing exploratory data analysis, you have to give this kind of inferences to them. Then they will be very happy. Other than directly building the model and saying, you say that, hey boss, we observed this kind of pattern given data set. Okay. Okay, further you have to do multiple plots, then only you will get to know, okay, whether you will get to know is there any pattern without, just by visualizing we can see it. See here, I have calculated the correlation. So from this correlation matrix, what did you understand? What is your interpretation?
A negative correlation is high between age and losses. So it means as the age increases, losses increase.
Age and years of experience are very, very highly correlated. Age and years of experience.
Okay.
No, that will anyways be correlated because within age you increase the years of experience.
So it is not a statistical fluke, but it is reality. It is real. Okay.
Can we ignore number of vehicles as the correlation is very less, right?
Which one?
Can we ignore number of vehicles because the correlation is very less with respect to losses?
Yeah, you can ignore. You can have a threshold. If it is less than 0.01, then I will ignore it.
Then account number will go.
Huh?
Account number will go.
Account number is not at all required.
So that has no correlation at all.
No, not a correlation at all. Okay, you are seeing the correlation. Account number no way influence, right?
No, that's true. But I'm just talking in terms of the statistics.
Yes. So practically speaking, you would have removed account number before finding the correlation.
Yeah.
As the age increases, the losses decrease.
So age is a good factor to predict. Okay, what about gender?
So, to find the correlation for gender, we have to convert it, right?
I think we need to label it.
So that is why I labeled here. Gender definitely influence because here we are seeing married persons. Okay, here we are seeing visually the correlation. Instead of the number in these box plots, married people usually lesser losses compared to the single people. There is a slight variation. There is a visually you can see there is a correlation for the gender. If it is male married, one kind of correlation, and if it is unmarried, there is some kind of different classes are there. So we have to include these two. Even single, like married, sorry. Okay. Even here also, male and female. So male persons and female persons, that one also we have to include. But the correlation we cannot use, we cannot calculate with categorical data. That is why it did not come here. Even though you are using the complete data frame, df.correlation, it did not come because correlation will not occur for categorical data. You cannot calculate. You can check whether those are influencing or not by using box plot only. Box plot is the best method to say whether it is influencing your target variable or not. Okay, I have created the get dummies function. This one you know, right? Get dummies.
Yes.
Okay. So you can see here gender, male. Here you can see gender drop first equal to drop. So you know this function, you want me to explain again or can I go ahead?
Yeah, can you please briefly explain?
Okay, let me share. So you have a column named gender, let's say. Okay, here age. Maybe age is 20, 25, maybe 18. it is something like this. Okay, the customer gender is male. Again, the second customer is 1 minute. Charged. Male. The second customer also male. Third customer is female. It is like this. I want to include this gender to my model building. So, but I cannot include my model can understand only numbers. Any machine learning algorithm understand numbers only. So somehow I want to convert these gender into number. How do I convert?
One hot encoding.
One hot encoding. So one hot encoding. What is one hot encoding?
One of the two columns will be hot always.
One of the two columns. This. So what I can create is I can create two more columns. I will convert this gender column into two columns. Sorry, male gender, female gender. Okay. Let's say I create like this. And for male I will give 0 and for female I will give 1. So I'll 0. Oh, sorry.
You can do both male, no, Yuvraju?
What?
And you can do both male and say 1 and 0, right? If it is male, 1. If it is not, if it is female, 0 for male gender.
0, 1. If we have one more, so male gender is there. Okay. Now the third gender also is including, right, nowadays, transgender. Then what value will give? 0, 1, 2, right?
No, it will be 0 and 1 only, right?
Which
For
one?
all of them, it will be 0 and 1 only, right?
I don't want to confuse you, so I'm writing here. So now you can see, I converted this column into two columns. Okay, male gender, female gender. So male gender for this row, in this row, male gender is 1 because this customer is male. Female gender is 0 because this customer is male, not female. That is why it is 0, this row. When it takes this row, the third customer is female, so for male gender column is 0, but female gender is 1. Then what I will do is, I will delete this. Now are you clear? You can use, so gender column I converted into two columns. Now as this is numbers, I can use for model building. Do you agree or not?
Yes.
What I will do is, I will delete this also. I use only this one for my model building. Is it okay or not okay? Chandra. See, I deleted gender column. That is fine because from gender column I created two other columns. So it is male gender and female gender. That is fine. You agreed. So I deleted that one. In this I want to delete one. Is it acceptable or not acceptable?
Acceptable.
Why?
because the value in that the column you're removing is already known by looking at the other column.
Yeah. So if I hide it, so male gender, M gender is 1 means definitely the value for female equal to 0 right here. If you know one column, you will easily get to know other column here. If you know this, you can easily say what are these values here. Am I right? So if I hide it, okay, what is female gender here? What is the value here? Can you someone tell?
001011.
It means that gender, one column is enough to describe the second column also. Am I right? Do you agree with me?
Yeah.
So
Yes.
that is why second column is kind of duplicate. That is why one column is enough to describe the gender value in any row. So here 1 means male gender, here it 1 means definitely it is male only. Here it meant male gender 0 means it is definitely female. Here male gender value 0 means it is definitely female. So you need not to keep this one, you can delete this one. One column is enough to explain your data set. So how do you delete? See, raw data column you can delete it. How do you delete one? So for this, which function you can use it? There is scikit-learn one-hot encoding. There is one function is there, library. Or pandas dummies function is there. There are 2 functions. You can use anything. It will give the same result. Okay, one is pandas function. Another one is scikit-learn pre-processing function. Okay, what pd.get dummies? If I come to this, are you able to see this code?
Yeah.
So if I use this column and drop first equal to true, if I use what it will do is, gender is having 2 categories. So it will create 2 columns and it will drop first column because one column is enough to explain the gender value in that data set. And even here also, married column I am passing to the get dummies function and I am dropping the first value. So you will get only one. See here, and after that I am concatenating everything. You can see here for gender male, we got created M and F, but I told you to drop one column. That is why F is not available here. For married also, married and single is there. And I told to the function to drop the first column. That is why married column is dropped and only single column is kept. Then what I do now is I drop the gender and married column also. Now you can see account number, age, years of experience, number of vehicles, losses in thousands, just male and single. Only these things are my columns. So I can use these things for machine learning. Okay. And one more thing. Till now, any doubts? Is this data ready for prediction?
We need to check for null values and other kinds of difficulty
Very good. Very good. Yes, you have to check the null values. You can say all are non-null. When I use info, right? All are non-null values.
Yeah, maybe not null, but we need also. We need to check whether we need the data exactly in right format.
Okay. How to check?
Initially, one way to do is like to find all the unique values and verify if in any series if the unique values are expected. like for example, let us say in age or any one of these, we may not need some values, right? Like 100 or 102 age.
So any outliers are there or not, you have to check. And
Correct.
false values are there or not. Yeah, age actually, whenever the banks are giving loan, they will check whether the person is 18 years old or not. So if the value is negative values are there or not, those things you have to check. Yes, exactly. So maybe the best way is whatever you are telling is right. Maybe I can do the describe function. Describe function will tell minimum, maximum, mean, 25 percentile, 50 percentile, 75 percentile, all those things, right? I will tell you.
Yeah, for example, for married single, there can also be garbage values, right? That is what I meant.
Okay. Okay. Other than married and single, do we have any other value? Okay.
Like
that one,
clean
yes.
up.
Clean up. Yes. You have to check it. Whether is there any, how many categories are there in married column? How many categories are there in gender column? Yes, that's true. We have to check it. Yeah. Okay. I did not check it. That is true. We have to check it. What else? Okay, let's say I checked it and there are only two married and single and female and male. That is why without checking I got only one column for male, another column for single. I got it. Okay, now let's assume I checked it. It is not there, but maybe in the code I have not written. Now the data set is ready for prediction.
Yeah, I think we have to divide the data set into test and train data set.
Exactly. I will do that. Okay.
No need to remove this account number also, right?
Exactly. Yes. So we have to remove the account number. So what I will do, I have selected my X data. Y target variable is Y. So losses in thousands. And my X is age, number of vehicles, the column M, male and single. These things only I have taken for consideration. And after that, I have did the train test split. Data set size is 30%. And here I imported the model, linear regression model from sklearn library. And here I am calling this function, linear regression function. I fit this model. So whenever you fit model.fit, linear regression.fit, whenever you pass the training data, what will happen in the background?
I think it will run the gradient descent algorithm.
Yes, okay.
To find the coefficients of all the independent variables?
Yes, it will run the gradient descent algorithm and it will calculate the coefficients and it will calculate the intercept and it will be ready for prediction. Whenever you call this fit method, then what will happen? Whenever you call fit method and you pass training data, X train and Y train, it will calculate the coefficients and it will calculate the intercept and it will be ready. That is why after fit function I am able to print the intercept and the coefficient. Got it? Okay, now we can see later whether this model is predicting better or not.
So what is X train, Y train?
So you are splitting your data set into training data set and the test data set. 70% test size 0.3 means 30% of your total data randomly you pick it up and 30% of your total data set is for test set. Test data you kept aside and 70% of the data you used for fitting your model.
So here, the loss is Y and the rest are X, is it?
Which one?
No, what is X and Y basically?
Y is your losses in thousands. X is
Okay,
all
losses
these
in
columns.
Oh, got you. Yes.
Okay. So you pass to extract your independent variables, y try your dependent variable or target variable, and you want then whenever you do the fit function, then it will do intercept and coefficients. So this is the one. Okay. Then what I will do is I have calculated the prediction. So I pass out the x test value. What is this function is doing? Prediction equal to lf.predict underscore x test. What it will do here?
It will predict the losses using the test data and coefficients plus intercept.
Yes. So let's say
Will predict the risk in dispersing the loan.
yeah. So it will predict how much money thousands in losses in thousands it will predict.
Yeah.
Okay. Then we want to know it will predict. It is predicted. So all the prediction values are in this variable. Let me say now I would like to know whether my model is performed better or not. Then what I will do? I will calculate R2 square, and even I can calculate mean absolute error, anything. So let me see what is my mean absolute error and everything. So this is my mean absolute error. Okay, this is intercept. This is this is intercept. This is coefficients. This is my mean absolute error. This is my R2 square 0.2. So
Yes.
is my model is good or bad?
Have you reached?
That.
Yeah, 0.3 is very worst actually.
Okay, come on.
We don't have a better model. We did not build a better model. Okay, that one we forget out how to build a better model. What will be the better model? We will think of next sessions. Okay, we got the R2 square. We are able to say whether it is a good model or not. Now we have these coefficients. What is this 97 point or 136 points? What is this actually? What is this 136? Subhadeep.
Yeah. These are the coefficients.
Coefficients, yes. So some coefficients are negative, some coefficients are positive, some coefficients are 136 in the order, some coefficients are in the order of 1.-1. So the coefficient 136 and the coefficient -1.7. So is there any difference? If the coefficient is high, what it indicates?
Yeah, I think when the coefficient is negative, when that independent variable increases, the loss will
There is inverse relationship.
loss will decrease. Yes.
Yeah, that is true. That is true, yes. If the value is 136, then what it will tell?
Yeah, I think when the X variable increases by one step count, maybe the loss will increase by 136 times, right? It is
exactly.
very high increase.
So more influenced parameter, right?
Yeah, more influencing parameter.
So 136 is the more influence. So what is that 136 means? Which it is? What it is? Single. We have age, number of vehicles, male and single. So the column single is influencing a lot to your model. Okay. Age is influencing bit less, but married or unmarried, that is influencing a lot. And the next most influencing thing is gender, male or female. Those are influencing a lot rather than age and number of cars available. So that one we can interpret from this. There are two ways to calculate R square. R2's underscore score or linear regression model underscore dot score. So both will give same value. Both will give linear regression score only.
So one question here, Raju. In the previous exam, or scenario, we had this male, female only, right? Let's say more than two categories there. Can you drop like that? Wherever the category.
See, if you have 4 categories are there in a single column,
right.
Then what will do? PD dot get dummies will create 4 columns. So you can drop any one of the column. Remaining 3 will tell the, if you know remaining 3, you will automatically get to know what is the 4th one.
Okay, let's say I have a region or continent. Okay, so still should I be able to drop one?
Let's say you have Asia, Europe, America, and what else? These 3 continents are there. Okay, in your data set. So if you know one row, if you know, see, you know when a particular customer is not from Asia, not from America, then from where he will be.
Okay, good.
True, right?
Yeah.
Automatically you will get to know the 3rd part. So that is why you can drop one line.
So is there any logic like if the number of values are more, then don't consider, like let's say 100 categories are there. Okay,
100
then
categories are there, then each category how many rows of data is there, that matters a lot.
Okay, let's say it's evenly distributed.
Evenly also, if you have only 20, 20, 20, then that will not impact much.
Okay, so we can, so if like values are more, then we can ignore those.
You can ignore it, or what you will do is.
Can that be a rule? Okay.
You can ignore it, or you can make groups within the categories.
Okay.
So let's say there is a group, age group category like 0 to 5 years, 5 to 10 years. Okay. 10 to 15 years, 15 to 20 years, like that, up to 100 means you can get 20 groups, for example. 20 groups means it's a data set will become huge. Number of columns will increase a lot. Then what you will do, maybe up to teenage one group. Within the categories, you can group one as one category and make lesser number of columns.
Okay.
You are getting my point?
Yeah, I got you.
Yeah. Yeah. So this is simply we have to predict average flight fare for if you give the data distance, average weekly passengers, market leading airline, market leading share, average market leading fare, low price airline, low stock market share of low price airline, average low price airline fare, all those things if you know, we have to predict our target variable is average flight fare. So here, let me go to the one row of data, how it looks. CAK is let's say one city, MCO is another city. From this city 1 to city 2, what is the average flight fare? $122.47. The distance between these two cities is 860. Average weekly passengers is 276.84. And market leading airline, let's say maybe Air India is the market leading airline in India. Let's say Chennai to Mumbai, the airline which is leading that route is, let's say, Air India. So that company market share for this city 1 to city 2 is 75%. Okay, and average fare of market leading airline is $123. But at the same time, average, okay, and low price airline is in that route is DL. Let's say maybe Jet Airways or something. Market share for low price airline is 17.23 market share. And average low price airline fare is $118.94. So this is the columns we have. So do you have any doubts in this column? Please read that columns carefully so that you won't get confused. So here we have 999 rows, 11 columns, and I checked the nulls are there or not. There is no nulls in the data set, and I find what are the data types here. To check whether the data types are right or wrong, and I calculated the describe function here. So from this describe function, I can see that mean value of average flight fare is 163, but most of the time it is 161. So mean values are higher for average flight fare, but slightly. Mean value for average weekly passengers also is higher. Average weekly passengers mean value is 672.5. And most of the people are 404. So what is this mean? Mean is higher than mode. 50% is mode. Mean is 672. What does it mean? I see this.
High outliers.
Instead of outliers, you have to say some other word. Right skewed or left skewed?
Right skewed.
Right skewed.
Yes, exactly. So by seeing this data, you can say easily. No need of plots also. So this is 60, this is 59. Okay. Almost the same, so it's okay. 166, 167, it's okay. This is 34 and 26. Maybe there are some right skewed. This is also right skewed. Almost all the data is slightly right skewed. Let me plot the plots. See, you can see here average flight fare. There is a slight right skewed. Even distance also there is a slight right skewed. Average weekly passengers, it is completely right skewed. Similar thing is I have made the box plot. You can see there is a. That is why this tail is right side tail is the top a bit higher than bottom tail because it is right skewed. That is one thing. And there are some outliers in the average weekly passengers. That is why you can that same thing you can observe it. Box plot. So till now any doubts? Can I go further?
Yeah, okay.
So same scenario I have implemented for market share, average fare for most leading airline, market share of least price airline or low price airline, average fare for low price airline. So these are the distributions. Here you can see there are some right skewed distributions. So wherever the skewness is high, you can see there are some outliers. Even here the skewness is high, outliers are there. And so the average fare of market leading aircraft, most of the time it is between 100 to 200. Yeah, right? If you take this box alone, instead of tails. Low price airfare also it is around 100 to 175. I'm not finding much deviation. I don't know. Average, the distribution of most leading airfare, the distribution of low price airfare, this box I'm not finding any difference because this box starts red color around 120 to 175. Even here also. Okay. Here it is average most leading company airfare is 75 to 200. Yeah. So what I'm trying to say is average most MLA fare, average LPA fare. If you take both, there is a slight increment, more than 200 for average MLA fare, but average LPA fare is it is around 175. Most Q3, we have to take the Q3, and here you can see the Q3 it is around 200, and here it is around 175. So let me draw the bar plot here, count plot or count plot something. So what do you understand from here? X-axis is market leading airline, y-axis is count. This is AED variant plot. What did you understand from here? Can I say
WN has a higher market share?
Yes, WN and DL have highest market share in the leading airlines group. Okay. When it comes to low price airline distribution, here also WN and DL are the highest market share. So from this, what you can say is low price airlines are also market leading airlines. Am I right?
Right.
So if I do the bivariate analysis like correlation, so what did you understand from here? With the average flight fare, okay, distance is having around 0.58 correlation. This variable I can take it for prediction. But average weekly passengers, I think there is no influence. It is minus 0.12. Am I right? So maybe I can drop this if I want because it is very less correlation. Market share of MLA is 23.3. It is slightly better than weekly passengers. Average MLA fare is 0.98. So average flight fare, if I want to predict, if I know the most leading aircraft fare, that I will get to know easily. Market share of low price airline is having 0.45 correlation with average flight fare. So I will keep this one also. And average LPA fare, it is this one is 0.86. So I will keep this one also. So with this, maybe I can, if I want, I can delete, I can ignore average weekly passengers and I can keep rest of the things. Do you agree with me? If I want to build the model as it is having less correlation, maybe I can ignore this, not an issue. Even if I ignore this, I won't get any, my model performance will not be bad. So this is the distribution for market leading airline versus average flight fare. You can see here for some aircrafts, some companies, some airlines, average flight fare, the distribution is almost similar. For some airlines, the distribution is completely different. So it's a complex relationship actually. Average flight fare versus market leading airline. So what I am doing is I am ignoring these things because there are many categories are there, FL, DL, WM, all those things. So these things I am going to ignore while building the model. Okay, the same thing, scatter plot. You can say average flight fare versus distance. How much will be the correlation? It is a positive or negative correlation.
Looks to be positive.
Yeah. With weekly passengers.
It's a very low correlation, but positive maybe.
Yeah. So almost zero, we can say. It is a zero correlation. Market share MLA. It's here also it's not so good correlation, but here you can say average MLA fare. It is very good correlation. Average LPA fare, it is very good correlation. So as the average flight fare versus average weekly passengers, the correlation is not good. Maybe we can check if I transform this one into log transformation. Average weekly passengers, if I do the log transformation, whether I will get any correlation or not. So you can see here, flight fare versus log of average weekly passengers. Here also, are you getting any correlation? Here also I am not getting any correlation. So sometimes what will happen is when you transform the variables into log transform or exponential transform, if you do that, sometimes what will happen, you will get the correlation. So if any features are not correlated, right, linearly correlated, you can do the log transform or some transformation, you can do that. And you can check the correlation. If the correlation is still, it is less after the transformation, then you can ignore this column directly. No need to build the model by using this column. So that is another best practice. So instead of directly ignoring which is having no correlation for model building, you can do the log transformation, you check it. If it is not working, then you can ignore it. So this is the one, so I ignored it because there is no, I'm planning to ignore this average weekly passengers because even after doing log transformation, it is not giving any good result. So here I am dropping city 1, city 2, market leading airlines. These are all not the numerical values, so I dropped all those things. Now my values for X is the distance, average weekly passengers, market share, average MLF, market share LP, these things. Okay, I can ignore this one, but I don't know why I have not ignored. I am including in this model. For the best practice, you can ignore this column and do the model building. I did the same thing again. Here, train test split, all those things. Here, what I do is before building the model, I did the normalizing of the features. Why do we do the normalizing of the features? Just read min-max scalar, just Google it, what is. When you do the normalization, what will happen is, some models, especially KNN and SVR, those models usually performs better when you do the normalization. So linear regression, I don't see if you do normalization or not. It does not depend much. But for support vector regression, KNN regression, those models, normalization is, if you do the normalization, you will get better results. So, but as a best practice, whenever you are doing regression, use the normalization. So I normalized the features, X train N and X test N is my training data and test data of X. So I build the model. You can see this is the intercept and this is the coefficients. Okay, you ignore this one. This is without normalization. This is without normalization. Ignore this one. So you can, same thing, you are predicting the results. Finally, you can see here the score is 0.97. My R2 score is 0.97. Is it a better model or good model? Better model or worst model?
It's a better model.
Yes, it is because 0.97 is almost D81. So it is a better model. And even here you can see there is a coefficient of 301. So 301 means this coefficient is higher, means this feature is most influencing feature. So can you guess what will be the 301 feature?
Average MLA fare.
Yes, average MLA fare. Here you can see average of 1, 2, 3, 4th one. 1, 2, 3, 4th. This is the most influenced feature. Yeah, that's it. So if you want this Jupyter notebook, you can check with Abhijit. He can share these numbers.
So this data from where, like, where are you getting this data? Are you like, is this real world data or some sample test like this?
You can see this is from this ES department. ES Department of Transportation.
Okay. So you are getting it from here. Okay. And one question, Raju, like, okay, if these data are like, okay, have 1,000 or 10,000 or like say 20,000 observations, will like these models work when data is in millions or like even more?
Yes, it will work.
Okay, in that case also it will work. Okay.
Yes. My models are having 5 lakh rows of data.
5 lakhs is again 500,000. But like if we talk about lots and lots of data, then I think it will be a little more complex, right? Or will it be like this only?
I will tell one. If you give more number of rows data, you are giving more information. So your model performance will be better.
Oh, okay. So there also, like when we will create the training data and test data, we'll use the same kind of 70-30 kind of ratio.
Yes, usually people go 70-30 or 80-20, your wish.
80-20, okay. And do you like once you have built a model, do you keep on feeding more data into it to see how it is performing and making it like keep improving it, or how it is?
More data, no. When you are building the training, when you are building the model, whatever the data you have, you will include it. You don't sample out of that and build the model, no.
So you have built a model. Suppose you have built a model in your real life, okay, and you have this model ready. Now you will put it to use and you will start prediction. Now what will happen is your future data will come in going forward. So you will be like inputting that data also into this model and try to make it better, or how it will be like it will be automatically done.
So how do you maintain the model, right?
Yes, exactly.
That one I will tell you later.
Oh, okay.
Yuvraj, can you go to the previous case study? Actually, I have one doubt related to that GitHub miss.
1 minute. The session is over. If someone is not having any doubts, you can leave. Not an issue.
Can you just go to the like outputs where we receive the coefficient and intercepts, right?
Yeah.
So actually, like that 97 and 136 are like related to that single and married.
Yes. Married and single. Yes.
So, for example, if you build a model, I mean, like interpreting this in a mathematical equation, for example, y equal to a plus bx, something like that. So we will be getting like 136 into married, right? So whether we will like yes. So in case of that single, if he is if he is a single, like we will be inputting that 0.
Yeah, then he is not a single. So 136 into 0 here.
So like that 136 into 0 becomes 0, right?
Yes. Then losses in thousands will be less, right?
No, sorry.
Losses in thousands also become less.
Okay.
So if you are single, then your losses in thousands are higher. If you are not single, means it is zero, losses in thousands are less. Then that is good only, right?
Okay, I thought like some like we are I mean, easy like I think we are not. I thought like we are not getting married one intercept, right?
No. We are including here. We are including
married.
Married, no. Single M is male. Okay. Single and married. Married means single value becomes zero, right?
Yes, married means single value becomes zero. So like here we like in case he is married, like we are not including the coefficient for him, right?
We are not including the coefficient, not an issue, because one column is enough to explain the others.
Okay.
That is why we did not include.
So in case if we include that, like what will happen? This
let's see what will happen. You will get another coefficient. Instead of single, then I have to take. I dropped the column. Okay, I will share this data set. What you will do is, you remove this drop first equal to true. Okay, then you will get two things: single and married. Okay, and build the model. What will happen is this coefficient will be splitted. You will not get 136. You will get something else.
Okay, I got it. Yeah, thank you.
Yeah, this is the one. If you want, okay, this pitch is fine, or do you want any further improvement? I assume that you don't have many doubts, so I did not cover much of theory. If you have any doubt on theory, right, then please post it. I can cover, suppose in the video lessons, if some topic is not clear, all those things. Whatever the theory today I told, all are with my self-interest. But this gradient descent and this partial differential equations, because these are important to the model. These are all important to even some kind of interview point also. That is why I thought, okay, better to give some flavor so that you can read yourself. And if you have any doubts, you can come and come. If I don't tell at all, then you don't know that such kind of thing is there. That is why with my self-interest, I taught that gradient descent, all those things.
Yes, actually, like I mean, we understood this part. Like they, with respect to the math part only, there is some kind of confusion we have.
Yeah, that math part, yes, we should go step by step clearly, because I wrote 2 to 3 steps in a single step. Okay, that will be there. If you have any doubts, right, small doubt also, please post in WhatsApp. Whether it is, don't think that, okay, what others feel if I post this one. Maybe this is the small doubt. So people think that, no, that is not the thing.
So, Yuvraj, this is Vamsi. Will they be asking us all these, derivations and all in interviews?
No one will ask.
Okay. It is for our understanding, right? How the things work and to understand the model better, right? That is the objective, right?
Yes. What is happening, we must know, right? What is happening behind the background, that we must know.
Okay.
See, for some models it is easy, like linear regression, all those things. When it comes to support vector regression, right, it is very difficult to intuitively understand what is happening in support vector regression. It is very difficult to prove the mathematics and those things. But for linear regression, logistic regression, it is easy actually. You can understand the math behind that. So wherever it is possible, right, you understand the math behind that. There are some difficult things. Frankly speaking, support vector, it is very difficult to understand math behind that, because they use many algorithms inside algorithm, one more algorithms. Like that they use it. So those things, it's okay not to understand, because most of the people don't know. So you will not face any such kind of questions in the interview. So logistic regression. How was the session? Logistic regression session. Interesting? Or like confusion matrix confusing? Because I didn't see many doubts this time. I don't know why.
It was good. Like Kumar Mathuraman is a great teacher.
Yeah. Hello.
It talks about doing classification to two categories, right? And when we do classification to two categories, it can be visualized using a sigmoid curve.
Okay.
Yeah. However, when we do classification to multiple categories, how do you visualize it?
Okay. How multiple categories can be? Yeah, I will tell you.
Yeah, because it won't be a sigmoid curve, right? It doesn't have just two categories, two lines. It is more than.
Yeah, there are also sigmoid curve only we will use, but we will use a small trick here. Okay. I will let you know how to. Okay, your doubt is I can reframe your question. How to do multi-class classification using logistic regression?
Yeah, and how do you visualize that?
Yeah, sure. I will let you know. Yeah. Good question. Yeah. Any other questions before we start?
Yes, Yuvraj. So this is Vamsi. See, I mean, this is more generic question for both logistic and linear regression. So we are having this coefficients and intercepts, right? So we are actually getting it from the methods we are using in the Python. So let us say I have this test set and the train set. Okay, so if I want to, if I want to improve my model, right? Where should I change the model? So I cannot change the data set, right? That is not the correct thing to do, right?
Yes.
So how can I? Let us say I split my data sets into, or I may randomize. Do not standardize the random method and split the data set multiple times and run this algorithm multiple times, and I may get different coefficients with small changes. Am I right?
Yes.
So what is it that we can do to make this model much better? See, again, the coefficients and the intercepts are all dependent on data.
Yes.
Not dependent on our any of our human activity.
Yes. That is true.
What can we do to make this thing better? We are comparing the efficiencies, the accuracy and the R square, and we are doing all that stuff. But doing that, how can we improve our model?
Improve our model in the sense how to split the data based on that you are asking, or
no. Let's say I got some my model. I have a data set. I'm simply running my linear regression model. Okay, and I'm getting some coefficients and something, right?
Yes.
Let's say I got my efficiency to 60 to 65%.
Okay, accuracy.
Now I want to improve my efficiency of the model.
Yes.
So what parameters can we change to improve that? I see some coefficients are negative. I see some coefficients are positive. So that means they are directly proportional and inversely proportional, right?
Yes.
Should I, for example, these are my thought process basically. Let us say if there is something, can we remove the negative coefficients parameters from our model, which are actually responsible for decreasing the
accuracy. Yeah.
Right?
Okay.
There could be also some parameters which we cannot, which we should not remove because they are negative. Maybe we can use those negative values to improve our efficiency. So is this the correct approach, or how can we improve more? This is a general doubt.
Okay, so one way is somehow you need to change the coefficient so that you will get a better results.
Okay, yeah.
You are asking a broad and very broad question. There are multiple ways to improve your model performance. Okay. Actually, we will be getting a session on feature engineering or feature selection methods, and those things are there. Those things are to improve the model performance. There I will cover all these topics more elaborately.
Okay.
But anyway, you are getting early doubts. Okay, let us deviate for 5 to 10 minutes. Not an issue because it's an interesting topic.
So my point is, though we are doing all these calculations should be useful to us, right?
Yes, that is true. Let's say you have, so you split the data, train test split you have done. So you got some coefficients, theta naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x3. So your y, the r square or RMSE, all those things are depending on is theta naught, theta 1, theta 2 and theta 3. Okay?
Correct.
So there are two things. If to improve the model, let's say you use a linear regression. You got r square equal to 0.8. Okay? Or adjusted r square, let's say.
Okay.
First question is 0.8 enough?
Yeah.
Is 0.8 enough?
It depends upon the domain, right?
It depends on your project expectation, your customer expectation.
Correct.
So if he satisfies with 80% r square equal to 0.8, then need not worry, because need not to scratch your head, just to deliver the model. Okay. Let's say, then otherwise you feel that, okay, if I give 0.9, I may get some other extra, one more project. I will be edging with my competitors. Then there are two options. Either instead of linear regression, you go for some advanced algorithms, gradient boosting, or KNN. There are many regression models, XGBoost, LGB regression. There are many things out there. Or you go for neural networks also.
Okay.
You change the model so that for each model, these coefficients are different. So that is one step.
Okay.
You tried many models. Among that, let's say your linear regression itself is the best model. All these things are failed.
Okay.
Okay. Now also you are getting 0.8. So what are the possible ways to improve? First is you will try many models. Yeah. And among them, if you feel these gradient boosting, KNN, XGBoost, LGBoost, neural networks, all are not, let's say gradient boosting is 0.7, KNN is 0.65, XGBoost is 0.8, this one also 0.7, neural network is also maybe 0.78, something like that. Then what you will do? XGBoost is very complex model. So even though it is 0.8, linear regression is very simple model to understand and explain. So you, instead of XGBoost, let's say you go for linear regression. So all these models are failed because all these models R square value is less than linear regression. So now you want to improve this one, 0.8 to 0.9. Okay, so there are many possible ways. See, maybe the selected features, whatever you have taken, are sufficient. That is one question you have to think of. Of course, even for every model you have to think of, but even at the last stage also, the features what I have taken are sufficient. Sufficient in the sense, my features are really explaining the why. That is first question. So you have to do that analysis. And is it required any, let's say instead of normal x1, x2, x3, combination of these features like x1, x2, or x2 square, or square root of x1, x2, like that, can we do anything to get a better results?
Okay, so for this to do preliminary, we can use the correlation, right?
Features, okay, you will, let's say your customer gave 100 features. In that you use correlation, you selected 10. Maybe these 10 are not enough. So you will ask the customer, okay, you gave me 100. Do you have any more?
Okay.
You are getting. So even in the base 100 also, are we missing anything? Let's say out of 100 based on correlation, You have taken some features. Those features are sufficient enough or not, you don't know, right? With these 10 features, you are getting only 0.8. So you have to ask, okay, I have taken these features, because most of your projects will be agile projects. You will not go and after 6 months and you say that I got 0.8 only, but your expectation is 0.9. Yours will be agile methodology. You will be suggesting, you will be discussing with the customer what are the features you are taking, what you have observed from the data. Then customer means he will be mostly expert in domain, because he knows about his product and about his machine or anything. So he will say that, okay, out of this 10, maybe you can include one more feature. I have not given in this set of 100. I will give again, what is that? So all these discussions, feature engineering discussion, is not only with the domain. Based on agile methodology, it will evolve. I will tell you one thing. Whatever the question you asked, right, it is more elaborate and it is very tough to solve also. If our model is not performing well, it is very difficult to do the root cause. Not very difficult, it will time consuming process. In our complete project, to take 100%, if I divide your project into 60, right? No, two sets. 60% will go for EDA, feature engineering in this place. 40% only will go for model building and deployment. 60% of the time we will spend to find the right features, not on building the models, building the algorithms. Only even 40 also very high. Sometimes I will say 70-30 also.
Okay.
70% of the time we will spend for finding the right features, doing the exploratory analysis, data analysis, finding the correlation, understanding the problem statement. Understanding the problem statement means you know what you have to deliver, but deep diving inside the domain way, all those things. And study some research papers. In that area someone is already developed some kind of models, either machine learning models or physics based models. There will be many things will be there. Okay. Whatever I told is kind of features are sufficient. That question you have to answer. Polynomial features. Maybe you can apply principal component analysis, or you can apply regularization techniques. These are all part of feature engineering. Unless your features are good, your results will not be good. Okay. Anyway, I got the opportunity to inform you before starting logistic regression. There are other variants of linear regression. Do you know what are other variants of linear regression? Linear regression variants. Linear regression. LR means linear regression. So, linear regression variants, there are ridge, lasso, elastic net. These three are very much important. These are regularized version of linear regression. Very, very important. If you want to attend any interviews, you can expect at least one question among these three. If they want to touch upon any regularization, definitely they will go for ridge, lasso, and elastic net. So maybe in additional video somewhere we would have mentioned that. If not, please ask Abhijit to share the videos. If he does not have anything in his repository, please message me. I will send you the proper videos to read these proper videos or proper articles. Have you noted down these things? Subhadeep?
1 second, I'm just noting it down. 1 second. Done.
Okay, very, very important. I am telling you again because with my not only working experience, see, if linear regression does not work, right? If I want to my model in the form of linear form, means I don't want these non-linear models. My linear regression is not working well. Then I will go for ridge, lasso, and elastic method. Surely something will work out for me. Okay, this is my practical experience in my work, and also we will get many questions on these three things in interview. Okay, so here today we are going to cover these topics. Other than this, some more extra topics also. Precision. Other than this ROC curve, I will explain precision and recall curve. Of course, it is not covered in the class, but I felt it is important. So precision recall curve, I will be explaining other than this ROC curve. So pros and cons of logistic regression. Case study on logistic regression. Yes. So this is the introduction. You need not remember. Okay. Unless you want to become mentor like me. You want to teach someone, then you have to remember all those things. See, here I have mentioned to apply for a binary dependent variable. It is not only for binary, even for multi-class, but usually it is for binary dependent. Even you can use for multi-class classification also. Why it is regression? Logistic regression is the classification models, right? But why the regression name came?
Another way, instead of a line, we are trying to fit a kind of a curve here. So another approach of regression maybe.
Yeah, somewhere you are trying to a bit closer to the answer, but yeah, not accurate.
It's more to do with the correlation between two variables, wherein the results are very specific. Probably they are mutually exclusive as well. So wherein a straight line correlation is not possible. So either the model has to be one extreme or the other extreme, which are mutually exclusive. So how do we correlate such dependent variable is where logistic regression comes into play. In my own words, I guess.
Okay. Here the question is logistic regression. Are we using any regression here?
Well, it is not a traditional regression, but it's it's not like a linear regression, but yes, there is a regression method to it.
Yeah. Okay. So just I question you because of course it is expected that okay, it is a tricky question only. Logistic regression, behind the bars, it is using like linear regression only. It is using linear regression only. Okay, linear regression results we are converting into classification. Remember the logistic regression is nothing but linear regression plus sigmoid plus threshold equal to logistic regression. Getting? I will tell you why. So note down this point. Linear regression plus sigmoid plus threshold equal to logistic regression.
Yeah, this is where the confusion is, Jiraj. If it is sigmoid, how can it be linear regression as well?
I will let you know why. How? Okay. I will draw a small formula and I will subsequent slides I will tell you. Please note down this point. Okay. So before that, let us use some basic words. Arts. So usually in horse racing, people uses odds. So there is a relationship between odds and the probability. Usually in horse race, sports, gambling, epidemiology, there people use odds rather than probability. Probability of winning the horse in that race, probability winning of that team in the sports. Instead of that, people use odds of that horse, odds of that game. Those things they will use it. So, but odds and probability, there is a relationship. Odds and probability, there is a relationship. Okay, let us see what is this relationship. Odds is nothing but probability by 1 minus p probability. It is nothing but, what is p means? Let's say odds of winning, probability of winning by 1 minus probability of not winning. If you take any horse,
I think it should be probability of winning only in the denominator.
Probability of, okay. Probability of not winning. Now it is okay?
Yes, now it's okay.
Okay, good. 1 minus probability of winning or probability of not winning. So this is the odds ratio. So why I am explaining this one is how sigmoid function came into the picture. I want to explain to you. So when I take log of odds, then I will apply log in the right hand side also. So this is the log of p by 1 minus p. So odds ratio is probability of event occurring by probability of event not occurring. So it's the same thing. So if you want probability, odds ratio by 1 plus odds ratio. So in logistic regression, our output is probability. That probability based on the threshold, we will convert into 0 or 1. So here, if you see logit of p equal to a plus bx, so our regression line here. So when you convert this one, logit of p is nothing but natural logarithmic of p by 1 minus p. And finally, the p will become like this, a plus bx by 1 plus a plus bx. So same thing, what I can write is, if I divide e power a plus bx on numerator and denominator, then I will get 1 plus e power minus of a plus bx. So I will say a plus bx as z. So just remember this. The same thing, whatever, probability p equal to e power z by 1 plus e power z or 1 by 1 plus e power minus z. So 1 by 1 plus e power z is nothing but sigmoid curve. If you draw 1 by 1 plus e power z, you will get the sigmoid curve. So probability is nothing but the p equal to 1 by 1 plus e power z minus z means your sigmoid curve output is probability. So everyone is familiar with this formula, right? Sigmoid curve formula. Any doubts on this formula?
No.
So now I have a data x1, x2, x3. I have my model. My output is 0 or 1. So let's say it is logistic regression model. So what this model is doing, it is taking data and it is giving 0 or 1. What is happening inside the model? Can someone explain?
Prediction.
Yes. So to do prediction, what are the steps model is doing?
So model is finding the coefficients of a and b of x and then sketching a sigmoid curve.
So can I write like this? The data x1, x2, x3 First it will do the linear regression. Linear regression I will write z equal to a1 x1 plus a2 x2 plus a3 x3. Can I say this one? Because I have 3 columns of data, then I will get 3 coefficients a1, a2, a3 or theta 1, theta 2, theta 3.
And intercept.
Okay, intercept a0. Or you can ignore intercept also. Currently I am ignoring. Okay. a1 x1 plus a2 x2 a3 x3. Then what will happen? This is linear regression.
Then we will put it in the sigmoid formula.
So this is called a linear regression. Okay. You will. So here what you will do? Okay, let me add it. You will calculate intercept and the coefficients. Then you will transform this z into sigmoid curve or 1 by e power minus z. What is z? Is linear regression line or linear regression output. So that one you will transform to sigmoid curve. So if you transform to sigmoid curve, what will be the output? What is the output? Probabilities. You will get the probabilities as the output. These probabilities, let's say, this probability values after converting your probability values, y actual is this one, probability is this one, y value is 1, 0, 1, 1, 0, 1. Probability values are 0.5. Then this is also 0.5. This is 0.8. It is predicted 0.7, 0.4, 0.9, let's say. Then you will use some threshold value. So your after sigmoid, you will get the probabilities like this: 0.5, 0.5, between 0 to 1, any value. Then we go for y cap. So what is y cap is, we will decide one threshold. See, our output we want is 0 or 1, not 0.5, 0.5, 0.8, 0.7. Not, we don't want that values. We want 0 or 1. The patient is having cancer or not. But what is the output of sigmoid curve is? This is telling, this value is telling probability of that patient is having cancer is 0.5. Probability of the second patient is having cancer is 0.5. Probability of third patient is having cancer is 0.8. Here it is telling probability of fourth patient is having cancer is 0.7. Like that it is telling. But we want the result, whether the patient is diagnosed with cancer or not. That's it. So how you will do that one? Vijay, can you answer that?
No, Yuvraj.
So here you need to fix C. Sigmoid output is probability. That you cannot change. There you will fix one threshold. Sigmoid output is probabilities. Okay, here what is the values? Let's say x1 or whatever the values. So sigmoid output is probabilities. Then you will fix some threshold. Probability, if my probability is greater than or equal to 0.5, then I will make it as class 1. Probability is less than 0.5. I will make it as class 0. So here, what is y predicted? So here it is 1 or 0?
1.
1. Greater than or equal? Yes. Here?
1.
1. So this one?
Again
This
1.
is also 1. This is also 1. This is
0.
0. This is 1. So this is my prediction. So my actual is 1 0 1 1 0 1, but my prediction is 1 1 1 1 0 1. So there is one. What is this? False positive. Or simply there is one. At one place it made a one error. So these are the things are going on. So same thing. Okay.
So this is where I think my confusion is, Jairaj. So if you look at this actual versus predicted probability versus, which is also sigmoid, and then you have a threshold, right?
Mm.
Where is linear regression in this? There is no, to your earlier point, you mentioned that linear regression plus sigmoid plus threshold becomes logistic regression, right?
Exactly. So what is Z here?
Oh, so it's part of the model itself.
Yes.
Okay.
See, what is the difference between logistic regression here is, see, in pure linear regression, what you will do, you will use sum of square errors. Sum of square errors as objective function. But here there is a small change. You will use the log loss function as loss function. So in traditional linear regression, you have the loss function. We already explained to you. Sum of square errors is the, you have to minimize. Okay, I will come to that. Anyway, I will write now. Minimize sum of square errors or mean square, sum of mean square errors or something. Okay, let's say sum of square errors. Sum of square errors. So what is sum of square errors? Square error is nothing but y minus y cap. Your actual minus predicted, whole square you do, and you will sum it, and you do the average. If you have m rows of data, then you will average. So this one you have to minimize it. That is your objective function in linear regression. But there is a small change in this. This is called cost function, usually say. Cost function or loss function or error function. Not many people use this one. Instead of this, what we will use log loss function. Our target is to minimize the log loss function. So minus y log. Can someone tell what is the formula? Yes.
1 minus y.
Log. Okay, sorry.
One minus y hat.
So instead of mean square error, we will calculate log loss error. Why? Because we are transforming our linear regression results into 1 by 1 plus e power minus z. So we are transforming. So when you transform, right, to find the minimum value, it is very difficult with you will. Okay, there is another reason. We will come up later. Why we are not using sum of square errors? We are using log loss function. That is some separate topic. Let us ignore now. So we will use log loss function. Here also, our objective function is minimize that. See, in linear regression also, if you plot this sum of square errors, this is parabola only. Okay, sorry. Even this log loss function, if you plot it, it is also a parabola. If you want, you can cross verify it. I hope I solved your doubt or anywhere confusion. How do you minimize this loss function is by using gradient descent optimization algorithm. Even in linear regression, even in logistic regression, to minimize this error or minimize this loss function, okay, both the cases we are using gradient descent optimization algorithm.
This gradient descent algorithm, so like, okay, I understand that, okay, what is explained there, but is there anything like more to this algorithm? Like, how do we implement it, or do we have to implement it anywhere, or is it already implemented and we don't have to we just have to know about this term and we don't have to like do any implementation of this?
In neural networks, you have to choose which optimization algorithm you want. Gradient descent or oh my god, there are many other algorithms out there. Gradient descent. What is another popular one is there? RMS prop and another. There is one popular is there. Sorry, I forget. Because there are many optimization algorithms out there. In machine learning, linear regression and logistic regression, we use gradient descent optimization algorithm. Okay. But when you are implement neural network, you have to choose your own optimization algorithm.
Okay.
So there, at least you must know how these things works. You need not implement anywhere.
Yeah, that's what, like, okay, I feel the explanation is a bit less of how we are going to be using this gradient descent.
Where in the video lessons?
And the lessons.
Yeah, if you want, see, if you want me to explain, then we need another session actually. I understand you need a bit more mathematical way so that you can understand
Yes,
better.
exactly.
Yeah. That is not part of this session or even linear regression session also. So if you want, definitely I can help you. Okay, I will ask Abhijit to make another session so that I can. Even I am very happy to explain you in more mathematically. So whatever I learned, sometimes I feel like okay, I'm not explaining more mathematics because of time constraint.
Okay, that's fine. If Abhijit permits, I would be happy to go through this.
He can. If you are asked, right, we want this topic a more elaborate way, they can see. Such flexibility will be there. First, what we will do, I will ask Abhijit if any videos are there to post so that you can understand.
Yeah, that would be good. Yep.
And right now, I will send one Stanford University's about gradient descent, all those things. Okay. You can go through that article also. Still, if you have doubts, you please message Abhijit. We will arrange one session. Okay. Usually, why means see you will use it, but you did not go deep dive to apply machine learning techniques here. If you say okay, gradient descent optimization algorithm we use it, that is fine. And there are some other algorithms also are there. When to use what, all those things you must know. But whenever you are dealing with machine learning, you will deal only this optimization algorithm, gradient descent only. Whenever you come to neural network, right, there are many optimization algorithms will come. So you must know everything how it works and what are the differences at least.
Okay.
So I will send one Stanford University's one presentation, on PDF is there. I will send you just to go through that. If you all feel we need a session, definitely we can make it. Not an issue. Okay.
Okay, sure.
So same thing. What is happening inside the model? First, you will take the data. So you do the regression. So once you do the regression, what is the output? You will find the coefficients and intercept. So what is happening inside the model, I am explaining here. So after that, so here z equal to a0 plus a1 x1 plus a2 x2 plus a3 x3. Then find the probabilities. So after that, you will pass these results to sigmoid function. So sigmoid function is, it will give probabilities 1 plus e power minus z. So this z we are going to substitute here. So you will get the probability values between 0 to 1, any value between 0 to 1. Then you will make some threshold, p value greater than or equal to 0.5, p value less than 0.5. So this is 0 and this is 1. Based on that, you will decide. So it's clear? Any doubts?
Okay, in the second step, that is find the probabilities, that is where we are using the gradient descent, right? Like to minimize the log loss.
Oh, here.
Okay, here we are using. Okay.
Gradient descent will come in regression only. It will not come in classification.
Okay.
Because gradient descent helps you to find the coefficients.
It's okay. Yeah.
Okay. So what is the manual work here? See, threshold is the manual work. Am I right? Sigmoid function, this calculation also is just a formula. Here also there is not much. All the hard work is done here actually. In the first step, all the hard work is done. Finding the coefficients and intercept is the what your machine learning algorithm is doing. Okay. And after that, you are simply applying in a formula here, and after that, a manual threshold to whether it is 0.5 or 0.4 or 0.3. That is your wish actually, based on your problem statement. So that is why logistic regression is actually a regression. That regression results we are passing to sigmoid function and a threshold to find the class, which class it is. Clear? Log laws, to find the coefficients, right? To find the right coefficients, we have to minimize the loss function. Minimize the loss function. To find the, see, how do you calculate, see, how do you get the coefficients? First tell me. How do you calculate the coefficients for your regression, right?
This is slow.
A1, A2, A3, A0. How do you calculate? Whatever your A0, A1, A2, A3, that coefficient should have minimum loss. What is minimum loss? Minimum error with the actual and prediction. Okay, so what is the function? Minimum loss means what is the loss formula? Log loss formula. So log loss formula also we are using to find the right coefficients. Here only we are using log loss. Both are having parabola shape only. Both are having parabola shape only. Okay. So shall I proceed further? Okay.
Sorry, one more question on this log loss, right?
Mm-hmm.
So I think the idea is to lessen the log loss, and that way the regression is accurate, right? So
yes.
Is there any way we can do with the data, right?
Mm-hmm.
Basically to eliminate the uncertainty. Mm-hmm. That way the log loss is less during the coefficient during finding the coefficients upstream, meaning rather than just taking whatever data we have and then calculating this. Is there anything that we can do to the data itself, or is it recommended?
Let's see. Data is, if your variance is very less in your data, right? This values prediction is difficult actually.
Right.
So if you want to minimize the log, 1 minute, do not confuse you. See, to minimize the log loss or minimize the loss, whatever data you give, with that data only it will make. It will try to minimize the loss with respect to that data. If you give the garbage, with that garbage only, it will try to minimize the loss. So if you provide better data, you will get better you will get better coefficients. If you are not giving better data, you are giving it a garbage, it will calculate the coefficients for that garbage only. Okay.
Yeah.
So what is better data? That is the question mark here.
Right.
The better data is you should not have more extreme values. I mean to say, if your data is something like this, anyway we will remove in exploratory data analysis. Usually we will remove this data, we will remove it.
Yeah. Okay. So it is good to take out the data and then feed that data to the regression. That way the loss is less.
Yes.
Okay.
So objective is to minimize the loss function. Again, we already discussed. Minus y into log y cap minus 1 minus y into log of 1 minus y cap. So now we know how to build the logistic regression, but now we would like to know whether my logistic regression is performing better or not. So till now, how to build? Is it clear?
Yes. Yeah.
Okay. Praveen, you remind me. Last, I will explain you multi-class classification. Why I am giving only 5 to 10 minutes is logistic regression usually for binary class only. For multi-class, other than logistic, we have many other models: decision tree, KNN, Navy base, and what to say? Gradient boosting. There are many models out there. So logistic regression usually do for with its structure. It is only mostly suitable for binary class, but you can do multi-class also. I will tell you how. I will give you one rough idea how it works. But you need not implement multi-class for logistic regression. No one will ask you. So yeah. Confusion matrix. So you already know what is confusion matrix. So what is true? What is true positive?
Prediction and actual are same.
Yes. False positive.
Prediction is negative then when compared to the actual.
Prediction is positive, but actually it is negative.
Yeah.
What is true negative? Prediction and actual both are negative only.
Right.
Okay. And what is false negative? You are predicting it as a negative, but actually it is positive. Okay. One small assessment here. Now, can someone tell what is actual negatives, actual positives? Actual negatives. If I want, by see, I know true positive, false positive, true negative, false negative. So I would like to calculate actual positives, actual negatives from my data set. Can someone tell?
True positive.
Positives.
False negative is equal to actual positive. False negative. Fn.
How? False negative?
We predicted negative, but it is false, so it's positive.
So we falsely predicted as a negative, but actually it is positive. So yeah. That is true. Exactly. Yes. So true positive. Actual negatives.
False positive plus true negative. Fp plus Tn.
False positive. So Tn plus Fp. True negatives means we predicted negative, actually also negative. False positives means falsely we predicted them as positive, but actually it is negative. So it will be actual negative. So if I want to know total predicted positives, if I want to know predicted positives, yeah, Chandra.
True positives by.
No, I want predicted positives.
Oh, predicted positives.
I would like to know what are how many rows of data my model predicted as positives.
False positive.
False positive. So false, see, your model predicted, true predicted. Whatever is predicted true, that is, no. So I want positives. TP means true positives. Means actually positive, you are also predicted positive. This is false predicted. So falsely it is predicted positive, but actually it is negative. But I want predicted positives, right? So TP plus FP, simple. Predicted negative, Vijay.
Sorry, you're what was okay.
Predicted negatives. So what is the, if I want to know out of these, what is the predicted negatives?
False false positive.
No, false positive is predicted positive. That is
sorry, false negative and true negative.
True negatives. So this one you should not forget. So how to plot ROC curve? First, what is ROC curve? I don't want definition. Tell me what is written in y-axis, what is written in x-axis. Whatever you understand from the session, you please let me know.
True positive rate on the y-axis.
Good, good.
And false positive rate.
Super. So true positive rate and false positive rate. Usually how it looks. I have two things. One is something like this. Another one is let me change the color. This one, which is ROC curve.
The second one.
On the right.
Right one.
What is left? Precision recall curve. Okay, I will come to this first one later. So ROC. So how do you plot actually? So TPR versus FPR, that is fine. Can you plot manually with some examples so that we can understand easily? Okay. What is the time now? 12:06.
Yeah, I don't know how to plot it, but essentially we are checking whether so if the ROC curve is very good and if the model is very good, positive rate will be close to 1 for the data set. FPR will be close to 0. So that's why the curve comes very close to y-axis and goes very steep.
Exactly. Very nice. Very nice. So ideal ROC curve should looks like, let me change the color. Ideal ROC curve. So this is 0, this is 1, this is also 1. Because FPR and TPR is maximum between 0 to 1 only. So it won't go beyond 0 to 1. And ideal ROC curve looks like this. Ideal ROC curve looks like this. Okay. So if area under the curve on ROC curve, so area under this curve, AUC, how much it is? The green color line, how much is the area under the curve?
1%.
This is the, this is the limit, right?
Yeah.
So this value is 1 and this value is 1. So 1 into 1 equal to 1. Okay. What is this blue color line? Approximately you tell.
Maybe 0.9, 0.85.
0.9, 0.85,
approximately 0.9. So this is actual scenario. So this is hypothetical. In real-time scenario, AAC1 is impossible. Even by chance you have to suspect that model. Okay? By chance you get also, you have to suspect that model. So ROC 0.9 is okay, better model only. So ROC curve helps to find the area under the curve. So if you find the area under the curve, area under the curve is between 0 to 1 only. If it is around close to 1, then your model performance is good, your model is good, otherwise it is bad. So for that reason ROC curve will help. But how to plot ROC, let us do intuition. So we already know, this is the example of a COVID positive negative patients based on the fever levels. So I am taking this example because I want you to understand the specificity, sensitivity, true positive rate, false positive rate, all those things. For that reason, I am taking this example and explaining that. Today's session also it will take some more time. So if you have any issues, then we can skip this and go directly to another topic.
No.
Should we continue?
Yeah.
Okay. So we already know if fever levels are high, we can suspect that patient has COVID positive with the current scenario. Am I right?
Yes.
So COVID negative is green color patients and COVID positive patients are red color. We marked in this way like this. So this patient, green color circled patient, high level of fever, but still he is negative. Maybe instead of viral fever, some kind of seasonal fever. Okay, COVID positive patient, this guy is having less fever. Less fever means almost not fever at all, but still he is having a COVID. Maybe his symptoms are not visible currently his symptoms are, we are not able to find the symptoms like fever level. Even though he is having fever level COVID, even though he is COVID positive, but he is asymptomatic. So he does not have any symptoms currently. That is why his fever levels are also less. Maybe that is the reason. So these are hypothetical results because the data set also hypothetical. So let's say I build the logistic regression to fit the data. So I build the logistic regression. It is like this. So y-axis is converted into probabilities between 0 to 1. So what is this probability 1 is? Probability of a person is having COVID positive is 1. Probability of having a person is having COVID negative is 0. So this is the sigmoid curve for that. Let's say our scikit-learn logistic regression curve, what it will do is, so we already know after sigmoid curve it will go probabilities, we have to set threshold. So if I fit a threshold of 0.5, what my logistic regression scikit-learn is usually, scikit-learn default threshold is 0.5. You cannot change it. There is other way around to change the threshold, but default it will use 0.5. So 0.5 threshold if I use, this patient is COVID negative patient. This patient is COVID positive patient. So what are the things are misclassified?
Circled green and red.
Circled green and red. This patient also possibility of misclassified. This patient also misclassified. These two are COVID positive, but our model is telling those are COVID negative. This person is COVID negative, but our model is telling COVID positive. So there are two white dots. So what is this white dot? What is this black dot represents? The black dot says the probability of the patients are having COVID positive is higher than the white dot. Means if you put the threshold to this much, then your model probability results are probability of have. So if you set this, okay, simple things, no positives, no negative, probability, all those things. This is the threshold, this is another threshold. So which one will tell your model is, which one represents more, instead of, no, I want to ask the right question. Okay, if I face this threshold, then if I put this white threshold, your model output is more COVID positives or more COVID negatives?
COVID negative.
More COVID negatives. More COVID negatives. Let me fill here only. So if I put the threshold here, so we'll get more COVID negative or more COVID positives. So
COVID positive.
So my threshold is here. So you will get more COVID positives, your output. If I put a threshold here. So whichever is above this line are COVID positives, whichever is below this line is COVID negatives. So your threshold is high here, more COVID negatives you will get. Your output is more COVID negatives. Clear? Any doubts?
Raju, I did not understand that.
Which one, the second line or first line?
First one.
See, if you use the lower threshold, what is this threshold? Any patient below this threshold line, then those are all COVID negatives. Any patient above this threshold line are COVID positives.
Okay, above and below you are talking about.
Yes.
Okay, not within the threshold, right?
See, if you take this threshold, below this threshold are less COVID negative, above this threshold are higher COVID positive.
Okay.
So your model will give more COVID positive in the first threshold, lower threshold. If you are having higher threshold, your model will give more COVID negatives. So let's say if you take 0.5 threshold, then the patients above this threshold line are COVID positive patients. The patient below this threshold line are COVID negative patients. So in that way we can discuss. So let's say I have some test data, training and everything is over. Okay, this is my 0.5 threshold, whatever I have here. So this is my patients. Red color is COVID positive patients. Actually, those are COVID positive patients. Green color are COVID negative patients. That I already know. But I want to know how my model is performing if I use the threshold 0.5. If I use 0.5, how my model is performing. So if you use the confusion matrix, how many COVID positives are there? So, okay. Then someone tell what is true, how much is the true positive?
3.
True positive means how many are correct?
Predicted positive and actual positive.
So yes, so we predicted COVID positive how many and actually how many are there, so it is 3. So this is false positive. You predicted this guy as No, you predicted this guy as positive, but he is actually negative. So this is this value. Now what is this point? 1. So you predicted COVID negative, but actually he is positive. So this guy you are predicted COVID positive, but actually he is negative. So this one is true negatives. Out of 4 negative patients, you predicted them properly, 3 negatives. So what is the, so let's come to the confusion matrix again for the same thing. Actually is COVID positive, this is COVID negative, this is COVID positive, and again this is COVID negative, this is predicted one, this is actual. So true positives are people who had COVID positive were also predicted to have COVID positive. True negatives are people who had COVID negative were also predicted to COVID negative. False negatives are who had COVID positive, but the prediction says they are COVID negative. People who had false positives is people who had COVID negative actually, but we are predicting them COVID positive. So if you take our previous example, what is true positive rate? Here. What is false positive rate?
Both are 3/4.
3/4. Exactly. So how much it is? 0.75. So true positive rate is also called recall, is also called sensitivity. There are 3 names for true positive rate. Don't get confused. All are same formula. So this is positive. Specificity is nothing but 1 minus FPR. This is also 0.75. Okay, false positive rate. So there. Sorry, this is sensitivity. With the COVID negative, tell us 75% of the people with the COVID positive. Sorry, here. This is okay. I have this is specificity with the COVID negative. So 0.75. Specificity is 1 by 1 minus FPR. So true negatives, how many? 3. True negatives plus 3. This is 0.75. So FPR is how much? False positives by false positives plus
True negative.
Okay. So how much is the false positives? 1, right? So 3 plus 1, it is 0.25. False positive rate is 0.25. It is not 3/4. Just revisit. So we have to, it is not, this is 1 minus FPR. So there are 2 terms for sensitivity and specificity. Sensitivity will tell about COVID the positive things. Specificity will talk about the negative data, and the sensitivity will talk about the positive data. So ROC graph is true positive rate and false positive rate. False positive rate is nothing but 1 minus specificity. So what true positive rate indicate? What proportion of people with COVID positive were correctly classified? What false positive rate indicates? The proportion of people classified as COVID negative that are false positives. Any doubts here? Of course, the definitions are confusing. That is why we always draw confusion matrix and get it. need not remember many of the formulas and all those things. So now, let's say this is 0. My cutoff threshold value is 0. You have to read this presentation in this way. So my threshold is 0 here. So if threshold is 0, what will happen? You will predict everyone as COVID. You will predict everyone as COVID.
Negative.
No. COVID positive.
No, negative it will be if threshold is 0.
Threshold is 0. Below 0, whichever is there, those are negative. Below, above 0, whatever is there, those are positive.
Oh, okay. Yeah.
So everyone you predict COVID positive. So it's good only, right? So in this way, you won't miss any positive patient. All positive patients are correctly predicted. But you predicted all negative patients also as positive patients. So is it a good model or?
No, it's not a good model.
It is not a good model. But even though you predicted all positive patients as positive, but you predicted all negative patients also as positive. So it is not a good model. So when the threshold is low, then this is the issue. Your false positive rate also 1 and the true positive rate also 1. So that point is here. At 1, 1, we classified all COVID positive patients at the same time. We incorrectly classified all COVID negative patients also. So this point is not a good point. So in the TPR versus FPR, we draw this line, this point. This point is at threshold 0. Remember that. Let's go to another threshold. Slightly I will increase the threshold. So my threshold is, let's say, 0.1. So here how many we correctly classified? Okay. How many COVID positive patients are correctly classified?
3.
Huh?
3.
Okay, total.
4 also. This one also is correctly classified because this is above the line.
It's 0.5, right? It's
No, 0.1.
Oh, 0.1. Oh, 0.1. Okay.
So all 4 we correctly classified. This patient, this patient, this patient, this patient, all are above the threshold only. You can see here. If you draw a line on the sigmoid curve, everything will be above this. All 3, and this guy also above this threshold line only. So all 4 are correctly classified. So all COVID positive patients are correctly classified by our model. So this is 4. But if you take the negative patient, these 2 patients are correctly classified as the negative patients only. But these 2 patients, we are classifying them as positive patients. So 50% of the people classifying as COVID negative, we are predicting as COVID negative, and 50% of the people we are predicting them as COVID positive. So now, so true positive rate is 1, false positive rate is 50 or 0.5. So that point is somewhere here. So this point or this point, which one is good?
Second one.
Second one. Why?
Because we are reducing the error in positive rate. False positive.
False positives should be less. So what will happen is, in the second scenario, we are able to predict all positive patients correctly, but some COVID negative patients also we are predicting them as positive. So if you go to 100 patients to the hospital, then what will happen? 100 negative patients, if they go to hospital, there is a probability that 50% of them will be diagnosed as COVID positive because our model is wrong. Is it a good sign or bad sign?
Again, bad, but better.
Better, because if you go to first phase, it is predicting all COVID positive patients as positive, even negative patients also positive. What is the meaning? Whoever goes to the hospital, then you are treating them as COVID positive patients, then what is the consequences? The consequences is medical infrastructure issues. You don't have that much in medical infrastructure, that many doctors. So threshold is very much important to make the decision. So in logistic regression, threshold is very much important to make the decision. So that one you have to remember. I will take another scenario, 0.5 scenario. So this is, okay, not 0.5. There is some other threshold, higher threshold. My confusion matrix is like this. So out of all COVID positive patients, I predicted them 3 COVID positive and 1 COVID negative. So my true positive rate is 0.75. My false positive rate is 0. So this is the one. So here my false positive rate is 0, but true positive rate is 0.75. It means what is that? What is the implication here? It means what we can, okay, instead of I tell this one, you only tell.
It means that all the COVID negative people are identified correctly.
Yeah, exactly. Yes, yes. Yeah.
And one COVID positive patient has been
wrong
false.
prediction.
So if 100 patients go,
Prediction.
Nishan? So if 100 COVID positive patients go, so then you will tell them 75 people only COVID positive, remaining 25 you will send home. So they will happily spread all over the world. So which is best model?
Second one.
This is the best in the current scenario. Okay.
Yeah.
So whether it is best or not best, that depends on your problem statement. What kind of problem you are dealing with? What kind of project you are working? If you strictly says no, whatever you do, my false positive rate should be 0, then this model is good. So I have another thing. Threshold equal to 1. So when I put threshold equal to 1, then everyone I consider them as COVID negative patients only. So the confusion matrix will become like this. So here what is the TPR equal to how much? This point.
Zero.
TPR 0, false positive. So it's a useless model. So that is why the points it is, so 0, 0 is waste skill, no skill model, 1, 1 also it is not a skilled model. So if I draw a line, any value on this line is not a good model, because you are having 50% false positive, the same number of false positives and true positives. So it is not a good model. It is not a skilled model at least. So if I draw a curve by joining all these 4, then it will become a ROC curve. So ROC curve is nothing but the curve between true positive rate and false positive rate at
Thresholds.
At different thresholds. It's clear how ROC curve is generated?
Yuvraju, how do you determine how many thresholds you need to take
how many you need to check, right?
Yes.
First of all, before that, you should know how much false positive rate, true positive rate you want. What is your problem expectations? Let's say you take the project, even this COVID data set itself. So what is your expectation?
To screen all the COVID positive patients.
It should 100% work for all COVID positive patients. But it's okay, some negative patients, you consider them as a positive, not an issue. You will do that hydroxychloroquine or some paracetamol, they will sit in the hospital bed for 2 weeks and they will come back or sit. There is not much harm for them. But if you, in that case, what you have to do is, your true positive rate, you will fix 1. Okay. You will fix 1. And your false positive rate is open. Anything can be, it is not an issue. Then what you will do? To draw the plot, see, to draw the plot, how many points you need means, you need minimum some 4 to 5 points. Or no, to draw a curve, you need 2 points only, but 2 points will not work. So you will take here 1, here 1, in between you take any threshold and you draw the curve. Then you fix it. How much is the threshold? Actually, in Jupyter Notebook, there is one function. It will tell what is FPR, what is TPR, what is the corresponding threshold. You need not to draw. For all possible thresholds and for all possible FPR, TPR, some thresholds. Okay. Based on that, you can decide. Okay, which is better. Okay. Usually, you need some at least. Here, how many we draw, how many points we have, how many thresholds we took, 1, 2, 3, 4. So if you want to do manually, if you want to use Excel, maybe you can take 4 or 5. Then you draw the curve, then you can decide. Otherwise, in Jupyter Notebook, we have the facility to select all these FPR, TPRs and thresholds.
But it is critical to find out which point is lying close to y-axis, right?
See, that is what you have to go for 0, 0. Okay, then 0, 0. This is true positive rate, and this is okay. Thresholds, right? Thresholds, yes, that is true. It is very difficult because you have to fix threshold and you have to check. You have to fix threshold and you have to check. Yeah, that is why you have already Jupyter Notebook. You have one function directly. You can use that one. Otherwise, randomly you have to go keep on checking. I hope I answered or I confused you.
No.
You're
good.
Okay. So don't worry, but this is the manual way to check it. See, everyone what they will do, they will check 2 extremes. See, if this is your sigmoid curve. You will check here, you will check here, you will check here, you will check here. 0, 0.25, 0.5, 0.75 and 1. Or at least you will take 5 to 6 points and you will check it. Based on that curve, you can easily estimate what will be the threshold. So not an issue. So this is the threshold curve. So this is our curve. So comparison of 2 models. Let's say you have logistic regression model and that curve is blue color curve. So this is logistic regression. And this red color curve is random forest. So usually if you want to compare 2 models which are best, then you will calculate the area under those curves. Whichever the curve is having highest area, that model is the best model. So area under the curve will help to compare 2 models. So which curve is having more area under the curve? You see red color or blue color?
Red.
Yes, good. So let's go to precision and recall. precision and recall. So this is precision and recall is very simple to remember. Both, so I'm just giving a hint. Both are having true positives on the numerator. Precision is based on the predicted positives. How many total number of predicted positives are there? Recall is based on the actual positives. So how many total number of actual positives are there? So precision will talk about this row. Recall will talk about this row, this column. If you want to remember blindly, precision and recall. So precision will have number of predicted positives. If you still want to remember, it depends on false positive. Recall is depending on false negatives. This is F1 score. What is F1 score? So F1 score, I will say, is it discussed F1 score in the class?
No.
F1 score is mean of precision and recall. This is the formula. Do you agree with me or not?
Can you please explain?
So F1 score is the mean of precision and recall. If you want, you can verify with this formula. So do you agree with me or not? So why I am questioning is you should not forget a feature. That is why I am questioning all these things.
No, actually, can you please explain this formula?
This is 2 multiply precision multiplies by recall by P plus R.
I think it's not clear when F1 score is going to be used.
That one I will tell you. First, did you understand this formula? This is the mean. What does this mean actually? We have statistics. We have 3 means. One is arithmetic mean. AM, arithmetic mean, geometric mean, and harmonic mean. What is arithmetic mean? That is the mean we are talking about regularly. P plus R by 2. What is geometric mean? Square root of P into R. What is harmonic mean? 2PR by P plus R. So it is a harmonic mean of precision and recall.
Okay, but what is harmonic mean?
See, what is mean here? You are averaging, right? Somehow you are clubbing together precision and recall. 2 variables you are clubbing together. So how in the mean you can club like this, or you can multiply them square root, you can do that one, or you can multiply them and divide with the P plus M. So these are the formulas. I am not going too much deep, but we should remember that we have 3 kinds of means actually: arithmetic mean, geometric mean, and harmonic mean. So for calculating F1 score, we use harmonic mean. Why? Really, I don't know. But in any scenario, if you take, this is the reason. Harmonic mean is smaller than geometric mean is smaller than arithmetic mean. If you take any 2 values, maybe you can compare. Okay. So now the question is when to use F1 score. I will come to that point. See, F1 score is a combination of precision and recall. So for we want for any model high precision and high recall. High precision and high recall. That is ideal situation. Is it possible? For a single model, high precision and high recall is really not possible. So you need some trade-off between precision and recall. So that is why we use F1 score. F1 score is nothing but the trade-off between precision and recall. Or what does this geometric mean will do? So F1 score is nothing but the trade-off between precision and recall. So you want a good precision, you want a good recall, but those two are different scenarios. How do you club them? So you need to club those results, right? So how do you club this? By using F1 score. So that is mathematical way. So in a simple terms, if you want to trade off between precision and recall, then you will use F1 score. So if your F1 score is very good, then your model is good. F1 score is bad, your model is very bad. So this is the precision recall curve. If you draw for different thresholds, right, whatever we have done previously, you take one threshold and you calculate the precision and the recall, and if you plot it, it looks like this. So if you take any threshold, suppose in this curve what you understand is if I want a good precision, then how much will be your recall? So what is the formula for precision? True positives by true positives plus what it is? What is the formula for recall? So if you want highest precision, then what will be the impact?
I think the issues, I think the model probably is not practically possible.
Highest precision, highest recall, it is practically not possible. That is why you need some trade-off. In between values, you have to take it. Okay. You have to take in between values. Even in between also, either you will take this one. What is this value around? Precision 0.8, recall around 0.8. So it is a good model. Yeah. Recall it depends on false negatives. What I wrote, sorry. Yeah.
Or P and R if we interchange.
Yeah, so I replaced. Yeah. That's my bad. Okay. So you need some trade-off always. So how do you achieve? Some based on F1 score you can calculate because that will do trade-off between precision and recall. Okay. So Chandra, that's clear why we need F1 score?
Yeah.
So see, but even then, when do you use high precision, when do you use high recall? See, both will not be possible, but then I will tell some scenarios. You tell me there where you need higher recall or higher pause. Where you will consider higher recall you will consider or higher precision you will consider. That is important, right?
It depends upon the scenario, right?
Exactly. I will tell some scenarios. So in our COVID scenario, first input, we already know that one. So in our COVID scenario, which one should be higher?
Precision.
Precision. Let's see. See, this is actually COVID positive. This is actually COVID negative. This is actually COVID positive. It is actually COVID negative. So if you want highest precision, then what you will do? Your false positive should be less. Means you should not predict any negatives as a positive. Okay. And in recall, so if you have highest precision, what will happen?
Sorry, I changed my answer. It's recall.
Huh? Okay. If you want highest precision, you will get less recall. That one you remember. You know already based on this graph. So if you take highest precision, what will happen? Then you will predict all negative patients correctly, but you may miss some positive patients predicting correctly. So that is not good thing. So you should have less false negatives. What is false negatives? You are predicting COVID negative, actually they are positive. So this should be less. Then only your recall will be higher. So you should take care of higher recall rather higher positive precision in the COVID case.
You are maximizing the true positives.
No, both the cases true positives are there. Influencing parameter is false negatives only. See, in denominator and numerator, both the case in precision and recall, you have true positives. So that you leave it. If you want higher recall, you should. What is higher recall? If you want higher recall, you should have less false negatives. Less false negatives. What does that mean? So you should not predict COVID positive patients as COVID negative patients.
Yeah.
Sorry. You should not predict COVID positive patients as COVID negative patients. That is the fact. So let's say you predicted many actual COVID positive patients as COVID negative. Then what will happen? This F1 will become high. Then your recall will become less. So your model will fail. So in case of in the scenario of COVID, you should have less false negatives. Less false negatives means actual positive cases, you should not predict them as negative. So in this case, you need a higher recall. I will tell one more scenario. Instead of COVID, let's say you are making cancer patient. So he is having cancer actually, but he is having cancer negative, means he does not have cancer. You are predicting cancer positive and you are predicting cancer negative. So in this case, which one should be higher? Vivek? You need not to say direct answer. Let's say in this case,
in cancer, if the patient doesn't have cancer, we don't want to say yes, he's having cancer.
He does not have. So let's say he is having cancer, and you should not say he does not have cancer. What will happen after 1 month or 2 months? He believes that your statement is right, and he will not take any treatment, and he will die. That consequences are very bad. Okay. If you say to the patient, so this is very wrong. So what will happen? Your recall should be very high, so that your false negatives will be lesser. So even in cancer, any treatment, right? Sick patient, whether he is having cancer or HIV or anything, recall should be always higher. That is the advisable thing. And precision, you can compromise a bit. I will tell another scenario. Mahesh, you should tell. Spam or non-spam? So I'm getting Gmails, right? So Google will automatically move your mails, some mails as spam, and some mails which are not spam. Those things will move to inbox. So spam positive. So spam negative means it is not spam. So this is you predicted them as spam. You predicted them as no spam. So what is false negative? Mahesh. Yeah.
False negative means I predicted it as spam, but it is not spam.
So actually spam, but you predicted
Not
that as no spam.
Right.
What is false positive here? Actual prediction, if you take, actually it is no spam.
Spam.
Prediction is
Spam.
Spam.
Spam. Yeah.
So which one you want to maintain less? False negatives or false positives in spam scenario?
Yeah, I don't want. Yeah.
False positives we want to reduce.
You want to reduce false positives. Why?
Yes. Yes.
Because you will miss some important mails. Actually, it was not spam, but your predicting is as spam, and you will lose it.
Exactly. Very good. Actually, see, even if it is Gmail is pushing some spam emails in inbox, as a reader or the owner of that, as a receiver of that email, you already know whether it is a spam or not. You will move to spam manually. But if you miss any important email, that consequences are very high, right? So in that case, you will try to maintain less false positives. Less false positives means less higher precision. So in this case, you will try to make precision is more important than recall. Accordingly, your F1 score also will come. So yeah, any doubts? Okay, I will tell one more thing.
So one question here, Raju.
Yes, yes.
So how the we understood that in different scenario we need to choose precision or recall, right? But how the F1 score will behave in this case? It will be less, more.
Yeah, let me tell one more example, then we'll discuss. So there is a pregnancy case. Okay. So pregnancy positive, you have it, you did the test, pregnancy positive. Actually no pregnant. She's, and you predicted them as pregnant in a woman, and you were telling no pregnant. So false negative, what it is? Actually it is pregnant. You are predicting that no pregnant. It is actually pregnant, actually no pregnant. You are predicting pregnant. So which one you want to maintain less? Chandra?
Yeah, FN.
So who are actually pregnant, you should not say you are not pregnant. Good. What about FP? If I say the non-pregnant woman, if I say you are pregnant, what will happen?
At least there is no life loss, so risk is less.
Yeah.
So there can be trade-off, not an issue. There can so safer side, what I will use is I will use F1 score. It is trade-off between precision and recall. Okay. So in many scenarios, even though you maintain higher precision, higher recall, whichever the scenarios you want, but most of the cases you will not be having such a huge tight things, your business problems. Let's say in my one of the project, what I have done is, power plant, right? A thermal power plant where electricity is generated. Have you seen anywhere near to your any mechanical engineers here? Hands up, please. Yes, no. Mechanical, electrical guys. Okay. So their coal will come from different countries. So they want to classify the coals. Which coal belongs to, they want to classify based on the calorific value. What is calorific value? Calorific value is nothing but based on how much energy it will come when I burn this coal. So in that case, right, that's why I want to predict good or lower calorific value coal or higher calorific value. Or simple terms, high energy coal and lower energy coal. So see, this case will not impact much life lessons, all those things. Which one you will take, precision or recall? You don't know exactly. Okay, in these scenarios. So safer side, what we will do is we will use F1 score, which is the trade-off between precision and recall. That is one thing. So in most of the real-time scenarios, in my project, whatever I have used that one, and to detect whether it is my machine is running. There are one more project whatever I have run, I have worked like. Okay, as a mechanical engineer, most of my data science projects are based on mechanical engineering model. There is one motor, whether I need to say whether the motor is running in a good condition or bad condition. I have to predict only these two based on the current data set. So in this case, what I have to do? I should not misclassify bad condition things. Even though if I misclassify good condition, it's okay. So that depends. What is your problem? What is your project? Where you have to concentrate? That depends. So you cannot compare precision score with the F1 score, or you cannot compare precision with the AUC score, all those things. Depends on what is the expectation from the project side. Which one you want to maintain.
So just a question here, like, okay, so basically we are using F1 score only when we want a good balance between precision and recall.
Yes.
Okay.
That is mostly, but most of your 90% of my projects, whatever I do, right, I use F1 score. That is practically best popular score. But some projects, whatever I have explained till now, the medical companies, COVID patient or cancer or heart disease, all those things, medical domain, or in machineries, whether you want to predict whether it is running good or bad. So based on the condition, whether it is precision as a your accuracy measurement or your recall as an accuracy measurement or F1 score, that is depends on your project. So which is good or which is best metric, no one can tell that. That is subjective actually. So if you don't know whether customer is expectation, recall or precision, if you don't know clearly, right, blindly you go F1 score.
Okay.
Blindly you go F1 score. You need not to calculate area under the curve, nothing. Those are all again complicated, nothing. F1 score is the most popular. Because F1 score works very well for imbalanced data set. Your data set is imbalanced, right? What is imbalanced data set? What is imbalanced data set?
Mix of positives and mix of COVID positives and negatives in the data set.
No, our data set should have positives and negatives. What is imbalanced?
Too much of ambiguity in the data.
Ambiguity in the sense?
Extreme. Sorry, go ahead.
Too many outliers.
Okay, we will tell in reverse way. Who said this one? Positive, negative? Huh? Praveen. Very good, Praveen. So, yes, exactly, but I will tell in real time scenario. See, if you take 1 million people, right, how many COVID positive patients you will get? Hardly 1,000. So, in your data set, 1 million rows of data is there means negatives will be 9,90,000 and maybe 10,000 is positives. So, if you take the ratio or percentage, hardly 5% of data is COVID positive and remaining data is COVID negative. 95% of the data is COVID negative. That rows belongs to COVID negative patients and 5% of the rows belongs to COVID positive patients. This is highly imbalanced data set. Okay. So, in this case, I will tell you one reason. If you take accuracy score, what? Let's say, so my data set is highly imbalanced. Now my accuracy score, right? Sorry, I did not tell accuracy score. True positives, false negatives, false positives, true negatives. This is actual, this is prediction. So what is the accuracy score formula?
TP plus TN divided by TP plus FP plus FN by TN.
So these diagonals divided by all four positives. Huh?
Yes, yes.
Tn, this is T, divided by TP plus FP plus Tn plus Fn. So what is this meaning? True positives means how many your model is correctly classified as positives. True negatives is how many your model is correctly classified as negatives. Okay. So accuracy score is nothing but out of, let's say my accuracy score 60 means what is that? %60 of your data is correctly classified. Remaining 40% is misclassified. Am I right?
Yes.
Yes.
That is simple. That is called accuracy score. Now, if my model is for the same data set, COVID data set, or any data set, medical, why I am taking medical data set is everyone can understand. So my model accuracy score is 80%. Is it a good model or not bad model?
Good model.
Huh?
Good model.
It depends, I think.
Oh, for my data set, you tell me.
It's a bad model.
Very, very bad model.
Very, very bad model.
Why? 95% of the data is having a negative data set. Your accuracy score is 20% means. What is the meaning? 20% of your data you are classifying wrong. So see, for this you need not to build a model. Out of 100 patients, okay, if I say all are COVID negative, let's say, I don't build a model. All are COVID negative. If I say, all are, let's say, out of 100 patients, if I take all are COVID negative, then what is the accuracy of my model?
95%.
95%, because 95% of the people I correctly classified. So if my model is giving 80%, means it's very, very bad model. So you have to see the imbalance also. So in my case, if I want to say my accuracy score is around 99%, then only I can say my model is somewhat better. You are getting my point? Or any confusion?
Yeah, once again.
Yeah, super. See, so now I don't build the model. I have negative patients. Out of 100 patients, 95 patients are negative, 5% are COVID positive. Without building the model, I say that all 100 are COVID negative. Or my model says all 100 is, no, I don't build the model. By closing my eyes, I will say that all 100 people are COVID negative. So then what is the accuracy? My accuracy. What is the accuracy? Out of total, how many are correctly classified? Total is 100. How many are correctly classified now? If I say all 100 are COVID negative.
95%.
95 people, negative people are correctly classified, right? So 95 is the accuracy score. So 0.95. So without building the model itself, I can say 95% is my accuracy. So if I build a model, then how much I should expect?
Above 95.
Above 95. Then only my model is good. Otherwise, what is the use? I don't need to build the model. So your accuracy score is a minimum 99%. So what is 99? Then, okay, one more thing. 99, okay. What is 99 by 100? So your accuracy score is 0.99. What is the meaning? Out of all 100, you misclassified only one person. Am I right? But in this case, even the accuracy is 95%. How many you misclassified? You misclassified are 5 persons.
Yeah.
Here you misclassified one person. So if you want to build a better model, right, you have to check your imbalanced data set which is having. So if negative is having 95%, your model should have more than 95%. Then only you are building a good model. Otherwise, randomly I can pick, I will get 95% accuracy. I know I need not to build the model. So that is why accuracy score is always not a good metric, especially for imbalanced data set. So for that case, we will go for F1 score. F1 score is combination of precision and recall by P plus R, right? So it will nullify that whatever the error you make, then it will give better results. So even if you say 99, you cannot say, oh, my model is so good. The first score will definitely nullify that and it will give lesser than 99%. So that is why. So accuracy score, if you don't have a imbalanced data set, your data set is around 60% negative and 40% positive. Okay, even though it is imbalanced, but somewhat better. So in this case, you can use accuracy score or F1 score. It does not matter much. But if you have highly imbalanced, go for F1 score. So yeah, good. Let's go. So this is the one. So pros and cons, it's already discussed in class. It gives probabilities. So if it gives probabilities, what is the advantage? Based on the threshold, we can decide. Okay, whether it is 0 or 1. So that is one good thing. It can be easily scaled to multiple classes. Not easily, but okay. It is very quick to train, very fast and at classifying unknown records. Why? We are building a linear model. That is why it is very quick. So it is very quick to train and very fast at classifying unknown records because we are building a linear model. So it is easy, computationally less expensive. That is why we are telling it is faster. Classifies, constructs linear boundaries. What it is? See, if your data set is like this, if your data set is having two classes like this, as it is building linear boundaries, so if it is the case, logistic regression easily classify it. Okay, but if you take the scenario like this, this is one class, another class is like this. This is another class. There are two classes here also. Even in here also two classes, here also two classes. So the first class, the first scenario, logistic regression will work better, but the second scenario it will not work at all because it will try to build a model. It will try to cut the data set like this, or like this, or something like this. Whatever you do, there are many misclassification errors will be there. So if there is no linear boundary between these two things, right, then it is very difficult for logistic regression to build. You will get a lot of errors in logistic regression. So in this case, usually SVR or decision trees or remaining models work very well. Logistic, if the data set is like this, if two classes are overlapping one over another, it is very difficult to classify it. So that is the disadvantage of linear. If it is linear, the computationally fast, that is the advantage. But the disadvantage is non-linearity, it cannot take care. So interpretation of coefficients is difficult. Why it is? Because if it is z equal to, you are telling a0 plus a1 b1 x1 plus, sorry, a1 x1 plus a2 x2, something like that. After that, you are transforming in e power minus. So after transforming, so you don't know exactly the end result. If it is linear, you can easily say, okay, if a1 is high, then it is most influential parameter, x1 is most influential parameter like that. But as you are transforming into e power minus, then it is very difficult to say whether it is this higher coefficient is really influencing the end result or not. That you don't know exactly. So that is interpretation of coefficient is difficult in logistic regression. See, multi-class classification, see, we don't use in logistic regression much, but I will tell you how. Salary, this is experience. So this you want to, this is age. With respect to age, your salary also will increase. I'm sorry, I don't have ready-made slide. So this is your experience and this is your salary. And you have three categories: lower income, middle class, or middle income, higher income. So there is one group, salary is less, experience is less. There is another group, salary is high, experience also high. There is a middle class group. This is experience. According to their experience, but salary is slightly better than lower experience because, but still it is less. There are three classes here. Okay. So how logistic regression will work is, there is a concept of one versus rest. One versus rest. What is 1? If we want to predict lower income people, so this is L, this is M, this is H, let's say. So if we want to predict lower income people, then what it will do? L versus MH. What is MH? This is L, this is H, this is L. L versus MH means these two classes, I will write in the things. These two classes, it will consider it as a single class. Got it? So lower income versus these two classes you club. Getting? And if you want to predict middle class versus you club lower income and higher income people. If you want to predict higher income, H versus M, yeah. You'll club these two. So 1 versus rest. It uses that formula. So if you have 3 classes, then what will happen is it will build, for this it will build 1 sigmoid curve, for this it will build 1 sigmoid curve, for this it will build 1 sigmoid curve. 3 sigmoid curves it will do. And it will club all these 3 and build the results. Getting? Praveen?
Yes.
Any confusion here? So this in this way it will do actually. 1 versus rest. OVR. People will say OVR. Yes. Lower or some other. Medial. So for each one threshold. So this is the one. And let's go to the Jupyter notebook. Are you comfortable with this much long? See, some things why I tell with my self-interest is I faced while I was working, that balanced, imbalanced data set, all those things I faced actually. Okay, I faced real time. I don't know that, okay, for imbalanced data set, accuracy score is not a good measure. No one told me before. I kicked back by the customer, all those things. Then I realized, okay, accuracy score is not a good measure. I have to go for F1 score for imbalanced data set. It will give better interpretation. So those things I am telling with my own interest, so that you will not face during your project works or in the interviews whenever you. So, but many things which I cannot predict all your doubts and I cannot tell in the classroom. It's true, right?
Yes.
So your doubts you should mention explicitly in WhatsApp group. So why I am telling many times is I encourage you to ask the doubts. Please post your doubts, not an issue. It is possible to discuss in the class or not, that we'll see later. Post all your doubts. Okay. So this is the data set. See, our target here is loan status 1 means loan is sanctioned to the customer. Loan status 0 means loan is not. Are you able to see this?
No.
Still we are
No.
PPT on.
No.
Oh my God. Thanks. After half an hour, if you tell, then. Yeah, now?
Yeah, no, it is.
So this is very simple data set. Okay. So this is gender, this is married. Okay. The data set is bank loan actually. So loan status. So whether for given these columns of data, whether finally we approved loan. 1 means loan status. He got the loan. 0 means he didn't get the loan. That's it. So we have the information about loan ID, gender of the customer, whether he is married or not, whether he is dependent, how many dependents are there, 0, 1, 2 or 3 plus. Education, whether he is graduated or not graduated, self-employed or not, yes or no. Applicant income, what is his income or he or her income. Co-applicant. If two people are applying the loan, then what is the co-applicant income? How much loan amount they have applied? Loan amount term. So whether it is 360 months or 120 months or 240 months, something like that. So credit history. Credit history is something like CIBIL score. So 1 means very good score, 0 means very bad score. Property, whether his property is in urban or rural area or semi-urban area. There are 3 classes. So finally this is. So based on this, we have to decide whether we can approve loan to the new customer or not. So all these columns are clear, the data set.
Yes.
So there are some, loan ID, definitely it is not, it will not give any information whether we can approve loan to the new customer or not. So I will delete this one. Okay. Loan ID is like a customer ID. It will not help anything. So loan amount is mentioned at some places is 0. See, these many columns are there, around 23 rows of data. So no one will apply for 0 amount of loan, right? So here the data is not entered properly, so I will delete these rows also. Okay, there are other ways to fill, but okay, we are not doing any missing value treatment in this session, so that is separate topic. So I will delete these things also. And suppose gender male or female. So there are some blanks. So even this one also, you cannot fill randomly male or female. Either what you can do is, you can see what is the mode. Mode is most of the applicants are male or female, you check it. So if most of the applicants are male, maybe you can fill the missing values with the male. That is one vague idea. If you have any other crazy ideas, you can think of anything based on the data set and you can fill it. So that is one thing. And education, graduate or not graduate, so it is fine. It is nothing is missing. Self-employed. Some people did not mention whether they have self-employed or not. Around how many are there? Why counting should number? There are many people. Count 33. So 33 people, they did not mention whether they are self-employed or not. So how do you fill this one? Again, simple thing is mode. Whether it is mode means you check it, how many no's or how many yeses are there. If no's are high, you fill that one. That is one vague idea. Another simple idea what I can give is, you filter with graduate. Let's say you take the graduate and you take the, so the graduate, you will find how many no's are there, how many yes are there. So you filter with the graduate and you check it in self-employed, how many no's are there, how many yes are there. If no's are high, you fill those things with the no. So this is another way. You filter with another column and you group by with another column and fill it. So there are many ways to fill the. So there are many ways to fill the missing values, but for simplicity, I am deleting wherever empty values are there. Okay, loan amount to term also, there are many missing values. So all those things I am going to delete it. So let's go with, so loan amount to term. If I take value counts and if I do the normalize, see 360 months loan term is 85% of the people applied. So 180 months loan, 0.07% of the people applied. 480 months, 0.02 months. So if I do the count plot for the same thing, you can see here, only for 360 months many people applied. Remaining people did not apply. 360 months loan term is more popular than remaining months. So if you tell this information to the bank, what they can do? Okay, you forget about the prediction. how this is. See, if you tell to the bank, okay, most of your loans are 360 months loan, they are popular to give, our customers are more willing to take the months for 360 months. So they can plan their loans accordingly. Their loan products or anything, they can plan for that term. So they can, what they can do, they can modify their loan terms. Instead of 480 months or 240 months, they can go for 360 months period of loan. So accordingly, they can create their own products, loan products, or they can concentrate where short-term loans are very less here. So short-term loans customers are very less for that bank. 12 months, 36 months, 84 months. So what is the advantage of having short-term loans for the banks? Money rotation will be higher, right? Am I right or not?
Yes.
So money rotation will be higher. So maybe they are very weak in providing short-term loans. Our customers are not interested. So based on this data, they can plan, okay, short-term loans are less popular in my bank. Let us create some other loan products which are more suitable for short-term loans, and they can take the business decisions. Okay, this is not related to prediction. Just with this data, what we can predict and what business decision they can take, it is these kind of things. So I'm just giving some examples. So, but anyway, it is very much skewed. So what I'm doing is I'm dropping it for the simplicity. I'm dropping that column as it is very skewed. And you can see how many null values are there. In gender, there are 13 columns. And credit history, there are 50 rows of data is empty. I dropped all those things. Finally, this is my data set. So this is the describe function. So this is the one I finally left with 511 rows. So almost 100 rows I deleted. So this is the main. What this describe function will tell?
Five-point summary plus.
Exactly, 5-point summary plus
The count and the mean.
Mean and count, 5-point summary.
And
so,
salary.
So without the plots, it is a simple univariate analysis. Can I say? What is univariate analysis? Each variable, how it is, what is the pattern inside the data for each variable? Like instead of box plot, histogram, density plot, or all those things, this information we are getting. Even if you take the histogram, you will roughly see what is the mean value. If you take the box plot, you will see what is the minimum, 25 quartile, 50% quartile, 75% quartile, and maximum value. Only these things you will see, right? So non-visible representation of box plot and histograms is a describe function will tell. As Kinsey John told, it is a simple 5-point summary. So load status. So this is the one. 1 is approved, 0 is not approved. So 67 points, data points are up. 67% of the customer they approved the loan, 32% of the customers they did not approve the loan. That is the historical data. Okay, this is the x-axis is loan status, the color is telling credit history. So what you can interpret out of this? One is loan approval.
Yes, the other one is.
So if you have more credit history,
then less possibility of approval.
More possibility to get the loan. Orange is the credit history, good history.
Okay.
So,
Yeah, got it.
So this is just a univariate analysis for applicant income versus loan status. You can see there are some outliers. Okay, and co-applicant income versus loan status. Here also you can see, and here also loan status versus loan amount. All these things, just a univariate. So you can see there are some outliers. You have to delete them. And one more thing, Based loan approved or not, it does not depend on loan amount or vice versa. Because you can see both the distributions are almost similar, right? Loan status 0, for that how much loan amount they ask. Loan status 1, how much loan amount they ask. So loan amount is actually not impacting much whether it is loan, whether to approve the loan or not in this case, but in practical scenario, yes, it will influence. So let's go to the model building. So I drop loan status from the X data set, and Y, which is predicted, I have taken loan status as my variable. So you already know gender, dependence, education, whether it is graduate or not, credit history, all those things are categorical variables. So I apply get dummies function to convert categorical variables into one-hot encoded variables. Last week I already explained to you what is one-hot encoding, all those things. You remember, right?
Yes.
Yes.
So the same thing, but here more number of columns are such kind of columns. So here drop first equal to true means if you have in gender male and female, if you have 2 columns, then I am dropping female column and I am keeping only gender male, like that. So married yes or no, I am dropping married no and I am keeping married yes here. Even in the same thing, dependence 1, 2, 3 plus are there. I am dropping the column dependence 0. Similar way for other things also. So train test split. So train test split x comma y comma test size equal to 30, random state equal to 40. So what is x? I am passing my features, my target variable. Test size 30 means what is test size 30?
The minimum number to be taken.
30% of the data is for test set, and remaining 70% of the data for training set. What is random state?
Random state is we get same number of same data point to check. Like even if we run next time, we'll retain those data points.
Exactly, very good. So if you take random state 42 means, I will explain because I wanted to explain from so many days, but I did not get. But today I wanted to explain. See, you have 3 columns x1, x2, x3. Okay, for example, and you have 10 rows of data. Let's say random state 42 means randomly 3 rows of first row, third row, fifth row is calculated for test set, and the remaining rows will be used for training set. If you state random state 1 means maybe first row, 9th row, and 10th row is selected for a test set. Remaining things for training set. So if you don't fix random state, what will happen? Every time you run the model, now the rows which to be selected for test set, it will always change. So your model results will not be same. So whenever you run your computer, it will be perfectly one result you will get. And tomorrow, whenever your friend or your boss is asking to run the model and show the results, when you run the model, you will get different results because every time it will take different subset for test set and a different subset for train set. So if you fix random state 42 means how many times you run the model, it will always use only first row, third row, and fifth row for test set and 2, 4, 6, 7, 8, 9, 10 for training set. So you should fix some value always for random state. Clear? Any doubts?
Just a question, like this 42 is a random number, right?
Yes, you can use any number between 0 to infinity. Or even negative number also not an issue. Minus infinity to plus infinity.
Okay.
Any doubts?
Is seed is also same as random state? There is some term called seed is there, right?
Yes. np.random.seed. Usually in neural networks people use that terminology.
Okay.
So linear model import, this is I'm importing the logistic regression. So my model, I'm building the model logistic regression with the name log range. So I'm taking 1000 iterations. So I am passing the value x train and y train values both. And so I am training the model here. Now I am predicting. So you can see my prediction results are x test and prediction test. You can see my output is 1111000 like that. As logistic regression here, default it will use threshold 0.5. If I predict the trial set, it is prediction time. You forget about that. So this is the confusion matrix for training and testing. You know already how to interpret confusion matrix, right?
Yes.
Okay, I will take 27, 25, 399 if you take. I'm just plotting here. 27, 25, 399. So actual will come here or here.
On top.
Actual comes on the top.
Actually, in prediction, it will come prediction on the top. SKLM confusion matrix. Okay. Actual will come in the side. Okay. Getting?
So here it is opposite.
Yes, that is why for that reason only I plotted here.
Okay.
0, 1. Here also 0, 1. Getting?
That is also opposite. 0, 1.
Ah, yes.
Okay.
So that is why you should know how to interpret confusion matrix from SQL learning.
So can you please plot that true positive, true negative in that?
Ah, yes. Here I am plotting. This is our true positive versus true false positive curve.
No, I am asking in the confusion matrix which you have put in Excel. So there, which is the true positive, which is the true negative, and false positive, false negative.
So 0, 0. Okay, this is
true negative.
A minute. Now 1 if you take positive, 0 if you take negative. Okay.
True negative.
This is true. This is 1 if you take positive. This is negative. This is positive. Sorry. Okay, both are in the same way. Right? Let me unmatch. This is negative. This is positive. Getting right? Now you can make it. This is true negative. This is true positive. This is what is it?
False negative.
False negative. Yes. This is false positive. Okay.
Okay.
So this is the curve. Okay. If you want, I will share you this code for you how to plot true positive rate, false positive. This is the false positive rate. Okay. If I want to know the best threshold, right? So I should include true positive rate and false positive. So if you want to know high positive, true positive rate, then how much threshold you will take? You will take this point, right? You want higher true positive rate. Hello?
Yes.
So you will pick this elbow point if you want higher true positive rate. If you want lesser false positive rate, then you will come down. So at this point, you can check what is the threshold. So you can see you will get in a single false positive rate, true positive rate, and thresholds with the function called ROC curve. With this itself, you will get all these three. At 0.8, this is maybe 0.9 true positive rate. At 0.9 true positive rate and 0.5 false positive rate, how much is the threshold? You can easily get it from this results. Okay, we are seeing this one, right? FPR, TPR, and thresholds.
Yes.
So you can build a model according to that threshold, so that you will get true positive rate. If you want end result, if you want more true positive rate.
So in this curve, I can see that, okay, this elbow is the place where we want for maximum true positive rate. But how do I get the exact value of this threshold?
Exact value, no?
Exact value means, yeah, this points, exact value.
You can draw an interactive plot instead of this plotly plot. Instead of this matplotlib plot, you do the interactive plot. Plotly plot you can do, right?
Okay, but like in this way, in this example specifically, how will you find out you're finding the threshold, right? In this using this plot, that which threshold will suit me. So how will you find that threshold?
See, first you want higher true positive rate or false positive rate? Which one you want?
Let's take true positive rate.
True positive rate. So what is the highest value over here? Highest true positive rate.
Let's consider the elbow only because it is giving me an ideal true positive rate plus false positive rate.
So this y side, how much it is approximately? 5.9, right?
Yeah.
So you go for 0.9.
But there is no way, without the interactive curve, there is no way to know it.
Otherwise, you know already false positive rate, true positive rate, threshold, right? Okay, you take the
threshold.
maximum.
I don't know. I don't know threshold.
No, you can get all three in a single function.
Okay, okay.
So true positive rate, you take the maximum of that. Okay, you take the maximum of that, means from here to here, anything you will get it. Am I right?
Mm-hmm.
So in that filter, you apply what is the minimum FPR. Then you will get this point.
Mm-hmm.
Got it?
Okay.
No, I am. See, your doubt is if I do this plot, how can I know exact value or that one, or
I want exact value of threshold for this point.
Exact value threshold. For each and every combination, you will have a threshold.
Yes, that's what. How will I find that threshold? Find that threshold.
You can see for ROC curve, this function will give for each FPR and TPR combination, what is the threshold?
Okay, so it will give me this. Then how will I find it out from this?
Which one? See, from this
suppose you run this code, right? This code which you showed, that function ROC curve. So once you have run this code, after that you want to find out this threshold for maximum TPR. So how will you find that?
So you plot this.
No, I don't plotting is visualization, but I want to find the exact value.
I will tell you. So you will plot TPR. You will have FPR. You can make a data frame, right, out of that threshold. So let's say 0.8 TPR and 0.5 FPR. What is the threshold? You already know already. You will be having the data set. What is the threshold? Maybe 0.2 or 0.4. Okay. So maybe here 0.8 TPR, but your false positive rate is 0.6, 0.8, maybe false 0.7, here so like this you will get the combination. Okay, here also you will get a 0.446, 0.511. So you will get the data set like this, right?
Yes, yes.
So you want maximum TPR. So all three are 0.8. Okay, these are all maximum. But at the same time, so you will filter 0.8. It is okay. So you have different FPRs. In that you want less FPR. So you take 0.5. Okay. So 0.8, 0.5 is the ideal one, right here.
So you like in real time you are using it like this, like you're mapping this threshold into an Excel and then doing all this stuff, or how it is in real time?
Yeah, in real time you have to make a data frame and you have to select which is the maximum, what is the ideal FPR ratio. Accordingly, you have to select the threshold.
So this like there may be like lot of values there. So what kind of logic are you using to like find out this? Because like okay, in this if even if in this graph only, if you will see there are a lot of values, right?
Which values here?
This threshold, TPR, FPR, there are a lot of values.
So which one you want here? This point, right? Is
so
it impossible to find out this point?
No, not impossible to find out this point, but like okay, at this point there are many thresholds.
No, at this point only one threshold will be there. For each point, one threshold only, right?
But this point is like okay, it's a straight line below that. So okay, yeah, that's true, correct.
For each pair of TPR FPR, you will have only one threshold.
Yeah.
You can use interactive plot and you can directly point your mouse. It will say what is the FPR and TPR. Correspondingly, you can go and search that FPR and TPR. You will get the threshold also.
Okay.
So that is all. Shubhadeep, it's clear the doubt?
Yeah, I will try it, and if in case like okay, I have more doubt, I will get back to you.
Oh, okay. I don't know exactly how you want. If you okay. So if I want to know better, okay, what I want to know is what I have done is simple. I want a geometric mean of sensitivity and specificity. Specificity is nothing but 1 minus false positive rate. So I want to consider both true positive rate and false positive rate. What I have taken here is geometric mean. So that is my own score. It is not given anyone from the like popular articles or anything. So I just created the geometric scheme because I want to consider true positive rate and false positive rate both in my calculation. So if I want to consider both, right, this dot point is there, right? This black dot you are able to see, right?
Yes.
So that black dot is my best threshold. So best threshold value is 0.73. My mean score value is square root of true positive multiplied by 1 minus false positive rate is 0.78. So for my formula, square root of sensitivity into multiply specificity, this is the best score. Now this point best threshold is this one. Okay, if you don't want this formula, if you use another formula like sensitivity plus specificity by 2, just instead of geometric mean, you can take arithmetic mean and you can do that also. But it's okay if you, that is your wish. So this is the curve for precision recall. Y-axis precision and recall. So precision and recall you can calculate based on precision recall curve. So there is a function here in Jupyter Notebook. So you have to pass y test and y hat, and it will give the result. You can see I want best F1 score from this plot. So what is the best F1 score? So if I take best F1 score, this is my, for this threshold, I am getting 0.876 is the threshold. This black point is my best F1 score. So in this way, you can decide what is the threshold if you want to get the best threshold, best F1 score. So if I want to get best F1 score, I need to use 0.511 as the threshold value.
No, but okay, I have a question here. What do you mean by like best threshold in this case?
If you want to get 0.876, see, logistic regression by default it will use 0.5 as a threshold.
Yeah.
So if you use 0.5 as a threshold, you won't get the F1 score 0.876. You will get lesser than that.
But why do I want to get a score of 0.876 only?
No. Among all the possibilities, you want a better F1 score. For your model, you want better F1 score, let's say. One minute. Maybe you are confusing, Supradeep.
Yes.
That is what I am thinking. See, what is the objective of your model? You want to get the finally better accuracy score or better F1 score, right?
Yes.
So better F1 score, how do you get it? If you are able to predict many things properly. Am I right?
Yes.
So how do you, the end results are depending on your threshold. If you change the threshold, your output also will change.
Actually, yes, that's true. So it depends. Everything depends on the threshold. So basically, we change thresholds. According to that, our scores will change. That's correct.
Our scores will change.
Yeah.
So you see for which threshold you will get the best score.
Okay. Got it. Yeah. So it will compute all the thresholds and all the F scores, corresponding F scores, and finally, which is the best F score for best threshold is what
yes,
you're
for which threshold you will get the best F score, you choose that threshold finally. Because threshold you can keep between 0 to 1 any value.
Okay.
You are getting my point?
Yes, now I got it.
So this is the end of the session. If you have any more doubts, you can stay. Otherwise, you can leave. Not an issue.
So Yuvraj, this method of calculating the best F1 score is done if there is no requirement of should have maximum recall or should have maximum precision, right?
Yes. If you want maximum recall, what you want to do? So you will come to this point left.
Yes.
Then that at that place, what is the threshold? You will check it and you will fix that threshold.
Correct. Only if there is no such requirement, then we can go with this method.
Yes. Yeah, see, I will tell the difference between stat models. It came when the statistics is born. Okay, these things. See, for every, what are the steps to build a model? First, you split the data, train data and test data, and you train your model using training data, and you test your model with testing data. So we have two functions for training. One function is for model.fit. For prediction, model.predict. We have two things. Okay. But what is happening is you train your model based on train data. So you can see model.fit, you can use it. But in stats model, you cannot do train and test splitting and you can predict only using test data. That is not possible in stats model. See, train, test. Okay. Machine learning, scikit-learn, what it will do? For training data, what it will do? Model.fit. Am I right? And we will pass X train, comma Y train. So model.predict you can do for X test and Y test. But in case of stats model, what will happen is it is possible only whichever the data you use for training, for that only you can predict. You cannot predict for untrained data. You are getting stats model. Stats model, okay, whatever the method they have. I'm telling similar method X train, comma Y train. You cannot predict using test data here. It is impossible.
So if you pass new data, like it will not be able to predict it.
No, unless you train, it will not predict.
Okay.
That is why stats model is not a machine learning model.
Okay.
That is that. Suppose you want to predict only for training data. X train, comma, Y train. You can predict whichever you trained also, right? It is possible in scikit-learn. It is possible in stats also. But for unknown data, you cannot predict it.
Then, Yuvraj, what is the point of training when you can't predict unknown?
That is not machine learning model. That is stats model.
Okay.
So their objectives was different before.
Okay. In some of the articles, I also saw this validation set also. Like instead of train set and test set, they are taking validation set also. So I mean there I learned that we will always optimize our model on validation set and then finally test on the test set.
Yes, actually, here for our simplicity we are using this. Slowly we will use that splitting also we will do in some of the classes. Don't worry, in upcoming classes. When you are building, see, validation, testing, that split, when it will help you is when you are building multiple models, if you want to select the best one, right?
Okay.
So that time it will help a lot. Training, validation, and testing.
Okay.
So this test set you will not touch at all until you finalize the which model you are going to use.
Yes.
With these two only you will play.
Yes.
Yeah, that we will cover, don't worry.
You mentioned this Rees, lasso, and elasticity.
Elastic net, yes.
That is for linear regression.
Yes, that is a variance, some variants of linear regression.
Right. And what about for this logistic regression?
See, there our end goal is regression only. Here our end goal is logistic classification. Don't club together.
Okay.
Those are
here do we have
any
such model? Yep, got you.
So go through those articles, Ridge, Lasso, and whatever. Maybe you might have seen some of the extra videos in linear regression. You will find those things. Important, okay. Please go through them.
How much of statistics do you use in real life, like as a machine learning or data scientist?
Whatever I teach you, right?
Not class. Statistics. Statistics means that one, hypothesis testing and what we did earlier. How much of it do you use in real life?
It's a very good question. In my manufacturing, I use very rarely. But if you go for medical terminal, medical field or pharmaceutical field or any supply chain field, okay, there maybe you use it. But even my friends are telling me.
Okay, so
not much actually.
So as a machine learning engineer or as an artificial intelligence
engineer? Rare. That is with my practical experience. Someone can deny with me also. Not an issue. If they are using rigorously.
Okay.
See, one scenario I will tell. See, for every second, 10,000 or 1 lakh clicks will happen in Amazon. Okay. You cannot take the huge amount of data for training or testing initial period. What you will do, you will take some subset of data.
Yeah.
So that subset is really coming from the population or not to check. What you will do? One sample t-test, all those things can be. One sample t-test, all those things are nothing but hypothesis testing only. Because there you will fix the hypothesis, sample mean and population mean are both are same. And alternate hypothesis is both are not same. Getting my point, right?
I'm getting it. Yeah.
So in that scenario, you may use it because you cannot use 1 crore or 10 billion rows of data. In that, you will take some subset and you will initially build the models. If you feel okay, these models can be used for that data, then you will expand your models. Otherwise, you will ignore that. Kind of proof of concept if you want to build. For that, you will not use a whole amount of data.
Yeah, okay, got it.
Thank you very much. See you next week with some other good algorithm.
So in this tutorial, you have learned about what is machine learning and what are the types of machine learning we have. And we have learned about supervised learning and what are the algorithm includes those supervised algorithms, right? So if you want to go for more content and more advanced content like this, then please go to Great Learning Academy, where you will get almost 80 plus free courses, and after completing your course, you can claim your certificate as well. And if you want to do your courses in a Great Learning application, that is also possible using Great Learning app. So please like the content as well if you like it, and please let us know in the comment how you feel about this tutorial. Thank you so much.